In the deep silence between stars where time unspools without witness, a wanderer drifts through the dark. It has no name from its origin, no tether to a parent sun. Astronomers call it 3I Atlas, the third known interstellar visitor to brush the shores of our solar system. But before it was given letters and numbers, it was something far older, a shard of forgotten creation, ejected from a world that may no longer exist. For millions, perhaps billions of years, it has sailed the galactic ocean, past cold nebulae and dim red dwarfs, past the invisible tides of gravity that bend all things. It moved, unseen, unknown, unclaimed, until now. Its path has carried it into the delicate clockwork of our solar system. Ahead lies the asteroid belt, a vast, turbulent graveyard of stone and metal. Thousands of shattered fragments from the dawn of planets circle the sun there, each an echo of a world that never came to be. For Atlas, the belt is no mere boundary. It is a trial, a crucible that may scatter it into dust or allow it to emerge scarred but alive, continuing its endless exile toward the outer dark. Astronomers can only watch, their telescopes straining against the faintest trickle of light. No spacecraft follows it, no instruments will touch it. What becomes of Atlas will be decided in silence, in collisions we may never see. Will this messenger from another star survive the gauntlet of ancient stone, or will it perish, erased without witness, returning its atoms to the same cosmic sea from which it once emerged? The answer waits in the shadow of the asteroid belt. It arrived without warning, as if the night itself had carried a secret too long hidden. A dim flicker of light, slipping through the deep velvet of the sky, betrayed its passage. To most, it was nothing, a pixel of movement lost in an ocean of stars, but for astronomers, that faint glimmer meant everything. They had seen such things only twice before. First in 2017, with Oumuamua, an elongated shard accelerating as if driven by forces invisible. Then in 2019, with comet 2I Borisov, a true comet, bleeding vapour as it tumbled in from the darkness beyond. Both came from outside, both were interstellar travellers, bodies born in alien star systems, flung across the galaxy, only to wander briefly through the embrace of our sun before vanishing forever. Now a third, 3I Atlas, a stranger in our sky. Its discovery was not glamorous. No dramatic sweep of telescopes across the heavens, no sudden revelation. It was the asteroid terrestrial impact last alert system, ATLAS, that noticed it, a survey designed to watch for threats closer to home. Its instruments are tuned to find small asteroids that might one day collide with Earth. But instead, they captured something profoundly rare, a traveller that had crossed light years to slip past us, a whisper of another solar system. From the start, its orbit was unlike any asteroid, unlike any comet bound to our sun. It was moving too fast, its eccentricity too high. It was not circling the sun, it was passing through, and its direction pointed not to the Kuiper belt, not to the Oort cloud, but to the interstellar void. That was the clue. Atlas was not one of us. It had no allegiance to this system, no history here. It came from elsewhere, born beneath an alien sun shaped by the chaos of some distant planetary nursery. Somewhere, perhaps millions of years ago, gravitational tides had torn it free. A giant planet's pull or a stellar encounter had thrown it into exile, and it had wandered ever since. For astronomers, the discovery was monumental. Each interstellar visitor is a messenger, bearing the chemistry, the composition, the scars of worlds that orbit other stars. A fragment of galactic history arrives unbidden, offering secrets without a spacecraft ever having to cross those distances, and yet each comes only once. Once they pass through, they are gone forever. The mystery of Atlas deepens in its fragility. While Oumuamua baffled scientists with its strange acceleration and Borisov behaved like a comet shedding gas and dust, Atlas seemed delicate, unstable, transient. Its brightness betrayed a structure on the edge of breaking. Some wondered if it would even last long enough to cross the inner solar system, or if it might disintegrate like so many fragile comets before it. And so, attention turned to its path. Calculations showed its trajectory would take it inward, skimming through the planetary orbits and then outward again, toward the asteroid belt. There, between Mars and Jupiter, waited a field of ancient rubble, a place where destruction and survival walk hand in hand. The asteroid belt is no uniform wall of stone, no impenetrable barrier. It is vast, scattered, a desert of emptiness punctuated by wandering giants of rock and metal. But the belt holds tens of millions of bodies, ranging from mountain-sized asteroids to worlds like Ceres. For an interstellar traveller, crossing such a domain is a gamble with chance itself. A near miss is survival. A collision could mean erasure. And yet, even if Atlas passes unscathed, the belt itself is not gentle. The faintest gravitational tugs from asteroids, the subtle pull of Jupiter's immense gravity, the relentless pressure of sunlight, together they may reshape its course. The asteroid belt is not just a graveyard, it is a crucible, a test. What makes Atlas a true stranger is not only its foreign birth, but its impermanence. Unlike planets or moons, bound for billions of years to the sun, interstellar objects are brief visitors. They come and they leave, and in their passing, they remind humanity of its own fragile position in the cosmos. Earth itself is but a small rock circling among a modest star, one island among countless others. Atlas carries the story of such islands, worlds unseen, suns unknown. Astronomers attempt to read that story through light. Every observation counts, the way brightness changes as it spins, the faint colours that hint at its minerals, the faint gases it may or may not shed. It is like deciphering a book where most of the pages are missing. But even a fragment matters. Even a glimpse teaches us what lies beyond. And here lies the wonder. Atlas is not a spacecraft. It is not designed, not engineered, not sent. It is a natural probe from another system, arriving by chance. It carries within it the chemistry of alien worlds, the dust of alien planets, the fingerprint of alien suns. In a universe so vast, so unreachable, such moments are priceless. For humanity, the arrival of 3i Atlas is both humbling and profound. The galaxy is not distant. It is not elsewhere. It comes to us. It drifts past our world in silence, unnoticed by most, yet carrying the weight of entire histories within its fragile body. And as it enters deeper into the solar system toward the waiting stones of the asteroid belt, the question emerges like a shadow. Will it survive? If it does, it will continue its lonely exile, passing back into the dark, a witness to our sun before vanishing into the gulf between stars once again. If it does not, it will shatter, its fragments absorbed into the ancient wreckage of our own planetary system. Its journey will end, but its atoms will remain, woven into the story of the solar system it only briefly touched. For now it is here, a visitor from beyond, a stranger in our sky. On the summit of Mauna Loa, where volcanic rock rises above the clouds and the air grows thin, the night sky stretches with a clarity found in few places on Earth. It is here, beneath the black expanse of Hawaiian sky, that human eyes have been sharpened into instruments of warning. The asteroid terrestrial impact last alert system, Atlas, keeps its silent vigil, scanning the heavens for dangers that might slip toward the Earth unnoticed. Its purpose is pragmatic, born from fear and necessity. History remembers the scars of impacts, the Siberian forest levelled in 1908, the Chicxulub crater where the age of the dinosaurs ended. Atlas was built to see such threats before they arrived, to give humanity a chance, however slim, to prepare. Its telescopes are modest compared to the giants that map the galaxies, but their duty is urgent. Find what moves, what shines faintly against the backdrop of eternity. On one unremarkable night, Atlas saw something new, a faint point of light, drifting across the sky, subtle, almost imperceptible. The algorithms marked it, cross-checking against known asteroids, comets, satellites, but the match never came. The orbit it traced was wrong. It did not belong. The discovery was made official in June 2020. Astronomers tracked the light carefully, calculating its trajectory, testing each hypothesis against the mathematics of celestial mechanics. The verdict was undeniable. The eccentricity of its orbit was greater than 1, an unmistakable signature of the hyperbolic path. This object was not bound to the sun. It had come from beyond, and it would not stay. Thus the catalogue gained a new entry, 3IR Atlas. The third interstellar object ever recorded, the third messenger from the galaxy itself. For the scientists who traced its light, there was both wonder and gravity in the realization. Every photon captured by their instruments had travelled across unimaginable distances. Every glimmer of Atlas was a story told across light years. It was not only an asteroid, it was a memory, cast adrift from a star that may no longer shine. In the history of astronomy, such moments are rare. Centuries passed when the stars seemed eternal, unchanging. Then came Galileo, who turned his lens upon Jupiter and found its moons dancing. Then came the discovery of Neptune, predicted in numbers before it was seen in the sky. Each revelation changed humanity's sense of place, and now the appearance of interstellar objects, Oumuamua, Borisov, Atlas, each carries the same quiet power. They remind us that the solar system is not an isolated stage. It is open, porous, connected to the galaxy in ways long imagined but seldom seen. For the astronomers in Hawaii, the discovery was humbling. Their system, designed to watch for local dangers, had caught something infinitely more profound, a fragment of another world's story. The Atlas telescope was never built to find interstellar travellers, yet it had become a witness to one. The light they captured was faint, fragile. Even the largest telescopes struggled to resolve its details, but its presence alone was a triumph. Humanity had seen the unseen. From the volcanic heights of Mauna Loa, a signal had been plucked from the deep sea of stars, proof that the galaxy does not simply surround us, it visits us. This fleeting detection carried enormous meaning for astronomy. With each interstellar visitor, a pattern emerges, hinting that such wanderers may be far more common than once believed. If 3 have been seen in only a few years, how many pass unnoticed, their light too faint, their path too brief? Perhaps millions drift through the solar system in silence, never caught, never named. The discovery of Atlas confirmed more than the existence of travellers. It confirmed the urgency of vigilance. Each new object is not just a curiosity, but a chance to understand what lies beyond. Through them, humanity studies the geology of alien planets, the chemistry of alien suns without leaving its home world. Each is a cosmic gift, a sample return mission delivered by chance across interstellar distances, and yet each discovery is also fleeting. The telescopes cannot follow forever. The faintness of Atlas meant that only fragments of data could be gathered before it slipped into invisibility once more. Astronomers scrambled to capture as much as possible, its brightness curve, its trajectory, its subtle changes as sunlight touched it. Every second mattered, because every second brought it closer to the asteroid belt and closer to vanishing. The night Atlas was named, the world did not pause. Humanity carried on with its routines, unaware that the sky had shifted. But in the small circle of astronomers who watched, there was reverence. They had been present at the moment when the galaxy whispered again. They had seen a visitor who carried the dust of another sun. Moments of discovery are fragile. They are the bridge between ignorance and wonder, between silence and revelation. In Hawaii, under the volcanic sky, one such bridge was crossed. The discovery of 3I Atlas was not just an addition to a catalogue, it was an affirmation. The galaxy is alive with motion, and the solar system is but one stop along an endless journey. The faint light that night was more than a detection. It was an invitation to ask where it came from, to ask how long it had wandered, to ask whether it would survive the peril that lay ahead, and above all to ask what it means when a fragment of another world drifts into ours, only for a moment, before returning to the silence between stars. When the announcement came that yet another interstellar object had entered the solar system, the world of astronomy trembled with a quiet astonishment. For centuries, the heavens had been imagined as a mostly closed system. The sun and its planets formed a family, bound together, isolated against the vast wilderness of the galaxy. The Oort cloud was seen as the frontier, the boundary beyond which lay only distance, silence, and stars. But the arrival of Oumuamua in 2017 shattered that illusion, and the discovery of Borisov in 2019 confirmed it was no accident. By the time Atlas was sighted, a third in quick succession, the shock was no longer in its existence, but in what its existence implied. The solar system is not a fortress. It is not sealed against intrusion. It is porous, fragile, open. Objects from other suns drift into it freely, pulled not by invitation but by the silent mathematics of gravity. The galaxy, once thought distant and unreachable, had proven itself immediate, interactive, alive with motion. To scientists, this realization carried both wonder and unease. For decades, theories had suggested that every planetary system must shed debris. During the violent youth of stars, when planets migrate and giant worlds stir the dust around them, countless shards are flung outward into the dark. Over billions of years, the Milky Way must fill with such fragments. Yet it was expected that these would be too rare, too faint, too scattered to ever encounter us. A handful might pass within light years, but the chance of one entering the solar system was thought to be remote, perhaps once in 100 millennia, and yet, within just a few years, astronomers had detected 3. What was once considered improbable now seemed inevitable. Perhaps the galaxy is thick with them, trillions of wanderers moving silently between stars, an unseen population threading the interstellar dark. The implications unsettled established thinking. If so many passed through unnoticed, what else might drift in? Could interstellar asteroids strike Earth? Could fragments of other planetary systems have already collided with ours in the past, leaving traces buried deep within Earth's crust unnoticed, their chemistry alien? The shock was not only statistical, it was conceptual. For centuries, humanity had pictured the solar system as a kind of cosmic island, separated by immense seas of emptiness. The discovery of interstellar bodies revealed instead that the galaxy is not composed of islands at all, but of archipelagos, currents of matter moving between systems, exchanging fragments like whispers between worlds. Philosophically, it rewrote the human relationship with the cosmos. The idea of isolation, of the solar system as a lone stage, dissolved. We are part of a galactic ecosystem, shaped not only by the sun's gravity, but by the passing tides of the Milky Way. And then came the deeper shock, hidden within the data. Oumuamua behaved unlike anything expected. It showed no cometary tail, yet it accelerated as if pushed by invisible hands. Borisov, by contrast, looked like a comet, but its chemistry suggested a richness not seen in local comets. And Atlas, fragile, unstable, seemed on the edge of disintegration before it had even crossed the belt. Each object, while sharing the trait of being unbound, carried its own mystery. No single theory explained them all. For science, this was profoundly unsettling. Interstellar bodies were supposed to be simple, rocks or ice, fragments of planet formation. But reality was proving stranger. Some seemed to obey the physics of comets. Some appeared inert, others defied explanation altogether. If just 3 discoveries had already broken expectations, what would 100 reveal? What hidden chemistries? What alien processes? What unknown mechanisms at work in other planetary nurseries? Astronomers began to speak not just of discovery, but of paradigm shift. The solar system could no longer be studied in isolation. To understand our world, one must now consider the interplay of many worlds, many stars, many histories. The cosmos is not a series of separate stories, it is a single interwoven epic, with fragments wandering freely between its chapters. Yet the shock carried another weight: vulnerability. If interstellar bodies pass through more often than imagined, the risk of collision grows less theoretical. Earth's history is written in impacts. The Tunguska explosion, the Chicxulub crater, even the smaller strikes that scar the moon, all are reminders that cosmic debris shapes destiny. What if someday one of these wanderers is not just passing through, but on a direct course? Its chemistry unknown, its speed immense, its warning time minimal? The thought unsettled even the most hardened of astronomers. But beyond fear lay awe. Each interstellar body is a messenger, a shard of a distant system. To hold in one's mind that the dust on its surface, the ice in its core once circled an alien sun, this is to glimpse the galaxy directly. No spacecraft has ever travelled so far, but fragments from afar have travelled here. The scientific shock of Atlas, therefore, was twofold. It confirmed what theory had long suggested, that the galaxy is full of fragments in motion, and it unsettled every expectation of rarity, safety, and simplicity. What was once considered extraordinary now seemed inevitable. What was once thought to be safe isolation now revealed itself as exposure. And what was once assumed to be uniform rock or ice revealed itself as mystery layered upon mystery. As Atlas continued on its path toward the asteroid belt, astronomers could only wonder, if 3 such objects had arrived in such quick succession, how many more waited in the dark? How many had passed already, unseen? Their presence marked only by the faintest shadow against the stars. The solar system was no longer an island, it was a crossroads. And in the shock of that revelation, humanity glimpsed both its fragility and its connection to the greater whole of the galaxy. For generations, interstellar objects had belonged to the realm of theory. Astronomers could trace the mathematics of planetary formation and conclude, with confidence, that countless fragments must be flung into the void when new systems are born. They could model gravitational slingshots, collisions, and stellar migrations, and predict a galaxy littered with wandering debris. But in practice, such visitors were expected to be rare beyond measure. The reasoning was simple: the galaxy is vast. Stars are separated by light years of emptiness, and their wandering fragments, though many, are dispersed across volumes so immense that the odds of one passing through a small solar system, let alone being noticed by human instruments, seemed infinitesimal. Some calculations suggested humanity might witness just one interstellar object per century. Others were even more conservative, predicting intervals of millennia. And then came the shattering of expectation. In 2017, Oumuamua blazed across the sky. In 2019, Borisov arrived, trailing vapour in its wake. In 2020, Atlas appeared, fragile and faint, yet undeniably alien. In only 3 years, the frequency was staggering. What was supposed to be exceptional now seemed routine. Astronomers were forced to ask, had they misunderstood the galaxy? Had they underestimated the true abundance of interstellar travellers? The conclusion, though tentative, was profound. If 3 had been found in such rapid succession, there must be millions more. They are not anomalies. They are a population, a hidden river of fragments drifting endlessly between stars. The implications ripple outward. If these wanderers are numerous, then every star system, including our own, must be shedding them constantly. Planetary birth is violent. Worlds form through collisions, through gravitational upheavals, through migrations that hurl debris into interstellar exile. Our sun, too, must have cast out countless shards over billions of years, now travelling anonymously through the galaxy, untraceable but real. Somewhere, another civilization may have glimpsed one of those fragments, an emissary of our own system passing silently through theirs. This abundance changes not only statistics, but philosophy. For if interstellar travellers are common, then the galaxy is not a collection of isolated worlds. It is a network of exchange, where matter moves freely between stars. Dust, dim-wound rock, perhaps even the organic molecules that seed life, all can travel on these interstellar ships of chance. Theories of panspermia, once regarded with caution, now gain a new plausibility. Life itself may not be confined to isolated cradles. It may drift, spread, migrate, carried on stones cast adrift in the galactic tide. Yet abundance also brings unease. If so many wanderers pass through, then the probability of impact grows sharper. Oumuamua passed harmlessly. Borisov disintegrated without harm. Atlas drifts toward the asteroid belt, uncertain of its fate. But in the long history of Earth, how many others struck? How many left their mark unseen, buried deep in ancient rock? Could the great extinction events, the sudden shifts in Earth's story, sometimes trace back to an object born beneath another sun? Astronomers now look to their instruments with new urgency. What was once thought unnecessary, a constant survey for interstellar bodies, has become essential. Facilities like the Vera Rubin Observatory, with its sweeping wide-field view of the sky, are expected to reveal dozens, perhaps hundreds of new interstellar objects each decade. With every detection, the statistics sharpen, the mysteries deepen, and the story of the galaxy becomes more vivid. But abundance does not bring simplicity. Each object so far has defied easy classification. Oumuamua, elongated and tumbling, accelerated without explanation, perhaps by outgassing too faint to see, perhaps by something stranger. Borisov behaved more like a comet, but its volatile chemistry suggested it was enriched in carbon monoxide, far more than typical comets of our own system. Atlas, fragile and dim, seemed ready to break apart at any moment. If they are common, then diversity must be immense. The galaxy is not delivering one type of body, but many, each carrying its own lessons, its own enigmas. This realization forces science to think differently. No longer can models of planetary formation remain narrow, confined to the solar system's own history. They must stretch across the galaxy, embracing the possibility that other stars forge planets in ways unlike our own, that their debris fields differ, that their fragments wander carrying chemistries unseen in local space. The sheer frequency also reshapes imagination. If travellers are so common, then the solar system itself must be a crossroads where such bodies continually pass. At any moment, perhaps unseen, another interstellar shard may be cutting through the outer dark, crossing the Kuiper belt, slipping past Neptune. Perhaps dozens are present at this very instant, faint and hidden. They're like too weak for human eyes. The thought changes the map of the cosmos. We are not alone in the void, not even in material terms. The galaxy is streaming through us. For astronomers, this brings both promise and pressure. Each new detection is fleeting. The objects move fast and they vanish quickly. Oumuamua was visible for only a matter of weeks before it grew too faint. Borisov lingered longer but disintegrated. Atlas, faint from the start, might disappear into invisibility even before its passage is complete. To capture their data requires vigilance, readiness and speed. The galaxy does not wait. And still the predictions fall short. If 3 have been seen, how many have been missed? If faint objects pass unobserved, then perhaps humanity has already overlooked dozens in recent years. Future telescopes may reveal that interstellar visitors are not only common, but constant. The solar system may be a perpetual theatre of encounters, its skies filled with silent travellers, noticed only when chance and technology align. In this abundance lies a paradox. What was once rare has become familiar, yet familiarity does not diminish wonder. Each visitor is still a messenger from the unknown, carrying secrets from beyond the reach of probes or spacecraft. They are the closest humanity has come to touching another star's story. The predictions were wrong, the expectations were broken, but in their breaking, the galaxy has opened itself. It is not distant, it is not separate. It is alive with motion, and its fragments pass through us continually. Atlas is one of them, one of many. And its fragile journey toward the asteroid belt is not an isolated tale, but a glimpse into a greater truth, that we live not in an island system, but in the heart of a galactic ocean, where the tides of stars carry with them endless debris, endless mysteries, endless chances to glimpse the wider universe. The shock of frequency is not only statistical, it is existential. If interstellar travellers are common, then the galaxy is not merely vast, it is connected. And in that connection, the solar system is not alone. It is part of a greater whole, whether through chance collisions, shared materials, or the faint exchange of ancient dust. Atlas drifts forward, one traveller among many. And its presence forces the question, how many others cross unseen? How many others will come, and what secrets do they carry in silence, waiting only for human eyes to find them? Every orbit is a stele written not in words but in the language of gravity. Planets, moons, comets all carry within their paths the memory of where they were born and of the forces that shaped them. To trace the trajectory of 3i Atlas is to peel back the layers of its history, to attempt the impossible, reconstructing the origin of a fragment that may have drifted for millions of years through the galactic dark. From the moment Atlas was catalogued, astronomers turned to mathematics. Its hyperbolic orbit, the unmistakable signature of a body unbound to the sun, told the first truth: it did not originate here. Its velocity, measured carefully, exceeded the solar escape speed. No encounter with Jupiter or Neptune could have flung it outward with such energy. The object entered our system already free, already travelling through interstellar space. Orbital mechanics allows scientists to play the story backward. By calculating its trajectory through the solar system and projecting the line into the past, they attempt to find the region of sky from which it came. The exercise is delicate. Every gravitational nudge, from the pull of planets, from the shower tide of the sun, alters the path slightly. And in interstellar space, even the faintest forces, like the tug of passing stars or the whisper of the galactic tide, can bend a course over millions of years. The uncertainty grows as the clock runs backward, until the precision dissolves into haze, and yet possibilities emerge. The calculations suggest that Atlas came from the direction of the constellation Serpens, slipping inward from a trajectory tilted steeply against the plane of the solar system. No known star aligns perfectly with this reconstructed path, but that is no surprise. Over the timescales required, stars themselves drift. The Milky Way is not static, it is a river of motion. Every star migrates around the galactic centre, shifting position over millennia. The home system of Atlas may no longer even occupy the coordinates from which it cast this fragment into exile. What might that home have been like? Theories of planetary formation provide a guide. When young stars are surrounded by swirling disks of dust and gas, planets form in violent competition. Some grow quickly into giants, their gravity disturbing everything around them. Smaller worlds collide, merge, or are shattered. In this chaos, countless fragments are thrown outward. Many fall back into the star, consumed in fire. Others are caught in the pull of growing planets, but some are ejected entirely, accelerated to speeds that break the star's grasp. They become exiles, interstellar objects, destined to wander the galaxy forever. Atlas is almost certainly one such exile. A shard from a planetary system in its youth flung outward millions, perhaps billions of years ago. Its surface may still carry the scars of that violent birth. Fractures from collisions, burns from stellar heat, the chemistry of minerals forged in an alien nursery. It is not simply a rock, it is a record, a geological archive of another world's beginning. Speculation stretches further. Could Atlas have been cast out by a giant planet, much like Jupiter once sculpted our own solar system? Could it have been born in a binary system, where the competing pulls of two suns made exile inevitable? Or perhaps it came from the crowded interior of a stellar cluster, where close encounters between stars constantly trade and scatter their planets and debris. Each scenario paints a different origin story. If from a Jupiter-like world, Atlas may be rocky, forged close to its sun before being expelled. If from a binary, its chemistry may carry exotic signatures, a mixture of elements uncommon in solitary systems. If from a cluster, it may have been wandering for eons already, long before our sun itself was born, carrying with it the memory of a galactic environment long gone. The timescales are staggering. Atlas could have travelled for tens of millions of years, crossing regions of the Milky Way no human eye will ever see. In that time, stars have lived and died. Civilizations, if they exist elsewhere, may have risen and fallen, never knowing that a fragment of their stellar neighbourhood had passed through ours. For Atlas, time is different. It drifts in silence, unchanging, while the galaxy itself evolves around it. Yet mathematics imposes humility. Even with the best instruments, the precise point of origin may never be known. The uncertainties multiply backward in time until the path is lost in probability. We may never name the star that birthed Atlas, never know the planets whose collisions created it. Its origin is written in mystery as much as in stone. But perhaps that is fitting. For interstellar objects are not emissaries with clear messages. They are whispers, suggestions of a greater story. Each is less about pinpointing a home than about realizing that homes exist everywhere, that every star casts its fragments outward, that every system contributes to the galactic sea. Tracing Atlas's path is not about finding a birthplace. It is about recognizing the scale of cosmic exile. It is about realizing that across the galaxy, the birth of planets always creates wanderers, and that our solar system itself has sent its own emissaries outward. Somewhere, far away, another civilization might already have glimpsed one, an object ejected from our sun's chaotic youth, drifting into their skies as strangely as Atlas now drifts into ours. For astronomers, the mathematics of its orbit is more than geometry. It is philosophy written in numbers. To follow Atlas backward is to confront the fluidity of time, the impermanence of origins. The realization that the galaxy is a tapestry of exchange. Each object carries fragments of worlds unseen, stars unnamed, histories unrecorded. Atlas is a stone cast into the cosmic river. Its ripples extend across epochs, across systems, across the very fabric of the Milky Way. And though its precise origin may never be known, its trajectory speaks a deeper truth, that we are not isolated, that the solar system is part of a network of migrations, of fragments moving endlessly, carrying within them the silent record of planetary birth and destruction. In its faint light, caught briefly by telescopes in Hawaii, lies the story of another sun, another world. A story written not in language but in motion. A story that began far away long ago and now brushes against ours for the briefest of moments before continuing into the dark. Atlas is not just a visitor. It is a survivor of ancient violence, a messenger of distant origins, and a reminder that every stone adrift in the galaxy is more than matter. It is memory. In the quiet corridors of observatories, astronomers turn their eyes not to grandeur, but to faintness. Three-Eye Atlas was never a spectacle. No blazing tail like Borisov, no strange acceleration like Oumuamua. Instead, it was subtle, dim against the backdrop of stars, its light barely rising above the threshold of detection. And yet within that faint glow, scientists sought the truth of its anatomy, the fragile details that would determine its fate. Unlike planets or moons, interstellar visitors are known only through their light curves, the delicate flickering of brightness as they tumble and turn. In Atlas, the light was uneven, suggesting a body irregular in shape. Perhaps elongated like a shard, perhaps fractured into smaller pieces, its surface reflecting unevenly as it rotated. No telescope resolved it clearly. It remained a point of light, but within the mathematics of its brightness curves, hints emerged. Its size could not be measured directly, but estimates placed it between 50 and 150 meters across, a fragment rather than a world, a stone adrift rather than a mountain. Its reflectivity, or albedo, appeared low, marking it as dark, carbon-rich, more akin to a cometary nucleus than a reflective asteroid. This darkness was significant. It meant Atlas absorbed much of the sunlight that touched it, warming quickly, making it vulnerable to sublimation and fragmentation. The brightness itself told a fragile story. Observations suggested that Atlas was already breaking apart, its structure weak, perhaps riddled with fractures. Unlike Borisov, which shed a comet's tail in predictable arcs, Atlas seemed unstable, as if its integrity had been compromised before it ever entered our system. Some speculated it might not survive long enough to even cross the asteroid belt, its pieces dissolving into dust before astronomers could learn more. The surface composition, though uncertain, hinted at volatiles, ices that could sublimate under sunlight. In interstellar space, frozen gases remain locked in place, untouched for millions of years. But as Atlas fell inward toward the sun, warmth awoke them. Jets of vapor, invisible from Earth, could have been pushing against its structure, widening cracks, hastening its decay. What appears as a single body in a telescope might already be a loose cluster of fragments, bound more by momentum than by cohesion. And yet, within that fragility lay significance. For if Atlas was rich in ices, then it carried the chemistry of a planetary nursery far beyond our own. The dust and minerals embedded within it were forged in an alien protoplanetary disk around a star we may never identify. Its weakness was not failure, it was memory. Memory of collisions, of ejection, of exile. Its fractures were scars, and scars are history written into matter. The question of survival loomed large. Could such a fragile object endure the trials ahead? The asteroid belt, with its subtle gravitational tugs, is not a wall of stone, but it is a place where chance encounters can shatter the weak. Even without collisions, the relentless forces of sunlight, the Yarkovsky effect, the slow push of photons, can spin such bodies into instability. A tumbling, thus fractured object risks tearing itself apart under its own uneven motion. Comparisons to Oumuamua and Borisov deepen the mystery. Oumuamua, though strange, held together. Its elongated shape, estimated at perhaps 100 by 30 meters, showed no sign of disintegration during its brief passage. Borisov, by contrast, shed material, but retained a coherent nucleus until it neared perihelion. Atlas seemed weaker still, as though its long exile had left it brittle, unable to endure the stresses of another star's gravity well. If Atlas disintegrates, what remains? Dust scattered across an orbit that may one day intersect with planets, moons, or other asteroids. A trail invisible to the naked eye, yet written into the solar system as a faint, anonymous stream of particles. To astronomers, such loss would be bittersweet. Data lost, yet a reminder of how fragile the messengers of the galaxy truly are. Its anatomy, size, shape, brightness also determined what could be learned from it. A small, dim object is difficult to study. Even the most powerful telescopes captured only hints, faint shifts in light curves, tiny variations in spectra. To know more required time, but time is never on humanity's side with such visitors. They move too quickly, fade too fast. By the time they are discovered, much of their passage has already unfolded unseen. Still, each fragment of information adds to a growing mosaic. The darkness of its surface links it to the family of carbonaceous bodies, rich in primitive compounds. The instability hints at a structure unconsolidated, more rubble pile than monolith, perhaps assembled from collisions in its native system. The faint gases suggest a heritage closer to comets than to dry asteroids. Together, they weave an image of Atlas as a fragile traveller, carrying within it the chemistry of alien beginnings, and in this anatomy lies the deeper reflection. Survival is not only about endurance. Sometimes fragility itself is the story. If Atlas shatters, its dust may seed the solar system with molecules alien to Earth. If it persists, it will carry those molecules onward, perhaps one day encountering another star, another system, another world. In either case, its journey is not meaningless. It is transformation, matter moving, exchanging, sharing across the galaxy. The anatomy of Atlas is not grandeur, but delicacy. A small body, a faint glow, a fragile traveller. Yet within it is a history older than Earth, older than the solar system itself. Its structure is weakness, but its weakness is truth. That the galaxy is not filled only with giants, but with fragments, each one carrying the silent testimony of the worlds that cast them out. Whether it survives the asteroid belt or not, Atlas has already told its story. It has shown that fragility is not the absence of meaning, but the presence of memory. That even the faintest, most delicate travellers can carry the weight of a universe. Between the orbits of Mars and Jupiter stretches a vast domain, a realm of rubble suspended in perpetual twilight. This is the asteroid belt, a boundary between the rocky worlds of the inner solar system and the giant planets that loom beyond. To the untrained imagination, it might appear as a crowded gauntlet of tumbling boulders, stones colliding in endless chaos. In truth, it is emptier than the myths suggest, yet its dangers are real, and its history written in ruin. It is here that Three-Eye Atlas must pass. A fragile wanderer from the stars drifting toward a region that is at once graveyard and crucible. For the asteroid belt is both the wreckage of what might have been and the birthplace of fragments that still endure. 4.5 billion years ago, this place could have been a planet. The material was there, stone, ice, metal, all gathered in orbit around the sun. But the pull of Jupiter, immense and unyielding, prevented assembly. Gravitational resonances stirred the disk, scattering would-be worlds, breaking their coherence. Instead of one planet, millions of shards remain. Some, like Ceres and Vesta, are vast enough to carry scars of internal processes, volcanism, differentiation, history frozen into rock. Others are no larger than mountains or mere grains of dust. For Atlas, the belt is a labyrinth. Though the space between objects is wide, hundreds of thousands of kilometers in most cases, the sheer number of bodies makes passage a matter of chance. The odds of a direct collision are low, but not non-existent. And even without impact, the gravitational influence of the belt's largest members can alter a trajectory subtly, pulling a fragile traveller into paths it did not intend. The symbolism is haunting. A fragment from a distant star, born in the upheaval of another planetary system, now faces the ruins of this one's unfinished world. Exile meets failure, survivor meets wreckage. What stories are exchanged in such encounters? To cross the belt is to navigate not only physical danger, but time itself. Every asteroid is a relic of the early solar system, its chemistry unchanged since the sun's birth. To pass among them is to drift through the archive of creation. Atlas, itself a relic of another star's nursery, now approaches these archives, two histories meeting briefly before parting forever. Astronomers calculate the likelihoods. The belt, though vast, is diffuse. A body like Atlas can move through untouched, as countless comets have done before. Yet chance does not care for significance. Even the faintest possibility of impact is enough to inspire unease. A collision with a kilometre-wide asteroid could erase Atlas instantly, scattering it into dust and shards that would never be distinguished from native debris. Its identity as an interstellar traveller would vanish, leaving behind only silence. But there is another form of destruction: self-fragmentation. The stresses of sunlight, sublimation of ices, the pull of Jupiter's gravity, each can unravel a fragile body. The belt does not need to strike Atlas directly. It may simply watch as the traveller collapses under its own fragility, joining the rubble as dust. In such a fate, Atlas would become indistinguishable from the ruins around it, absorbed into the unfinished story of this abandoned world. And yet, there is also survival. To slip through untouched is to emerge into the outer solar system, scarred perhaps, altered perhaps, but whole enough to continue. Beyond the belt lies Jupiter, Saturn, and the long road to interstellar exile once again. For Atlas, survival means return to the silence of the galaxy, carrying with it the scars of a solar system briefly touched. In contemplating this passage, astronomers reflect on scale. To human eyes, the asteroid belt is danger, chaos, possibility of collision. But to a fragment like Atlas, moving at tens of kilometers per second, the belt is mostly emptiness. Even in its densest regions, it is space that dominates, not stone. Perhaps Atlas will pass without incident, unnoticed by the larger bodies that circle there. Perhaps it will emerge intact, as countless comets have done before. Yet symbolism endures. The belt is not simply a physical obstacle, it is a mirror. For Earth itself lives in a similar balance, fragile, circling its star surrounded by remnants of violent formation. The asteroid belt reminds us that creation and destruction are inseparable, that every planet owes its existence to the fragments that did not assemble, to the collisions that shaped its orbit, to the rubble that was left behind. Atlas, by passing through, participates in this eternal balance, risking destruction to continue its endless exile. The perilous path ahead is not only about survival, it is about encounter. For in this crossing, humanity glimpses the intersection of two cosmic stories, one written in the violence of another star's youth, the other in the incomplete birth of our own solar system. Atlas carries with it the chemistry of alien beginnings, the belt preserves the chemistry of ours. In their near meeting, a dialogue unfolds, silent but profound. Will Atlas weave through untouched, or collide with an ancient relic of planetary formation? The truth may never be known with certainty. Its faintness may conceal its final fate. Perhaps one day astronomers will note its light vanishing sooner than expected, its trajectory altered suddenly, its body gone. Or perhaps they will watch as it drifts outward beyond Jupiter, dimming into invisibility, carrying on into the galactic dark. Either way, the crossing is a crucible, a place where fragility is tested, where exile meets ruin, where survival itself becomes a kind of meaning. For even if Atlas is destroyed, it will not be erased. Its dust will linger, mingling with the rubble of this unfinished world. Its journey will end not in silence, but in transformation. The asteroid belt waits, patient and indifferent, and into its labyrinth drifts the fragile traveller, carrying with it the memory of another sun. The asteroid belt is not merely a region of stone and silence. It is an archive of time, a library written not in words but in the language of matter. Every fragment that drifts here carries within it the story of a beginning that never reached an end. Each rock is an echo of what might have been, a world that almost formed, a planet that never was. 4.5 billion years ago, when the solar system was young, dust and gas circled the newborn sun in a glowing disk. Out of that disk, worlds began to rise. In the inner regions, Mercury, Venus, Earth, and Mars coalesced. In the outer reaches, Jupiter and Saturn grew immense, drawing in gas and sculpting their orbits. But between them, between the strength of Mars and the dominance of Jupiter, instability reigned. Gravity did not permit harmony. Every attempt at planetary birth was interrupted, every gathering of matter torn apart by resonances too strong to ignore. What remains is not a planet, but a graveyard. Millions of bodies, from dust grains to mountains, circle endlessly, never coalescing, never completing the process of formation. Some are rich in carbon, carrying organic compounds preserved from the dawn of the solar system. Others are metallic, fragments of cores that might have belonged to lost protoplanets. Still others show evidence of ice, the faint fingerprints of water trapped in their interiors. Each is a frozen witness to the solar system's youth, untouched by the geological churn that reshaped the surfaces of planets. To gaze upon the belt, then, is to gaze into the past. Earth has been renewed and reworked by tectonics, volcanism, erosion, and life, but the belt has remained quiet. Its bodies are time capsules, preserving a chemistry older than mountains, older than oceans, older even than the first stirrings of life. They are pages of the solar system's original manuscript, unfinished, unaltered, waiting to be read. For 3i Atlas, the belt is not only peril, but memory. A traveller born of another star, carrying its own alien history, now drifts toward the archive of ours. In this fleeting crossing, two stories converge. The debris of another world cast into exile across the galaxy meets the debris of this world's unfulfilled potential. It is a dialogue between pasts, between the chaotic birth of distant suns and the unsteady formation of our own. What wisdom awaits in such a meeting? Perhaps none, for Atlas cannot read and the belt does not speak. But in the act of crossing, meaning arises. Humanity, observing from afar, witnesses an interstellar relic brushing against the silent memory of its home system. In this juxtaposition, new questions form. What can be learned from comparing these fragments? What does alien dust tell us about our own beginnings? Could the same processes that failed here have succeeded elsewhere, casting Atlas into being? The belt teaches humility. Planets are not inevitable. They are fragile outcomes of a chaotic process, precarious victories in the struggle of matter against gravity and chance. For every Earth, there are countless failures, systems where planets never formed, or worlds that were torn apart, leaving only rubble. The asteroid belt is proof that not every beginning reaches fulfillment. It is a reminder that stability is rare, and that our own planet's existence is not guaranteed by natural law, but by fortune. And yet the belt also holds potential wisdom. Within its stones are preserved the primordial materials of life: carbon compounds, water-bearing minerals, the chemistry of possibility. Missions like NASA's OSIRIS-REx to Bennu and JAXA's Hayabusa 2 to Ryugu show that asteroids may contain the very ingredients that once seeded Earth. To pass among them is to pass through the laboratory of creation, where the molecules of life itself may have been forged and preserved. For Atlas, this archive is alien. It carries its own chemistry, perhaps similar, perhaps entirely different, but in its passage, humanity is given a metaphorical moment of comparison. One archive meets another. Our solar system's unfinished worlds face an emissary of a world beyond. Both are records, both are memory, both whisper that planets, life and histories are not singular events, but part of a galactic pattern repeated across the stars. What wisdom then awaits a traveller who dares to cross the belt? Perhaps the wisdom of impermanence, that not all beginnings reach completion. Perhaps the wisdom of connection, that fragments from different stars share the same cosmic stage, intersecting briefly before diverging again. Or perhaps the wisdom of silence, that the universe does not speak in human terms, but in the slow language of orbits and collisions, dust and decay. Atlas may not survive the crossing. Its fragile body may shatter, dissolving into the archive it sought to traverse. If so, its memory will be absorbed into ours, its alien history mingling with the debris of our solar system's youth. Or it may pass through unscathed, carrying its story onward untouched, leaving behind only the symbolism of its passage. In either case, the wisdom lies not in outcome but in encounter. The asteroid belt is not only a boundary, it is the mirror, reflecting the truth of all planetary system, that creation is incomplete, that loss and survival are intertwined, that the galaxy is filled not only with stars and planets, but with fragments of what could have been. To drift through it is to drift through the memory of time itself. And so Atlas approaches, fragile against the immensity, carrying with it the memory of another sun. The belt waits, indifferent, its stones circling as they have for billions of years. Whether Atlas survives or not, the crossing itself will be meaning, a meeting of archives, a convergence of unfinished stories, a reminder that in the vast library of the universe, even fragments have wisdom to share. Every crater on Earth is a scar, an entry in the planet's long and violent diary. The pitted surface of the moon preserves the record most clearly, untouched by atmosphere or erosion. But Earth too bears the marks, though wind, water and tectonic drift erase them over time. Each impact tells of a visitor that came too close, striking with energy beyond imagination. Most were local, asteroids and comets born of the solar system itself, yet some astronomers have begun to ask a deeper or unsettling question. Could a few of those scars belong not to native stones, but to interstellar projectiles? In theory, the answer must be yes. If trillions of fragments wander the galaxy, crossing paths with star systems endlessly, then some will strike worlds. Earth is no exception. The difference is subtle but profound. Local comets and asteroids move at tens of kilometers per second, but interstellar bodies, unbound by the sun, can arrive far faster. Their speeds may reach 50, 70, even 100 kilometers per second, delivering impacts with energies that dwarf even the greatest local collisions. Such an impact would leave devastation, yet it would also leave ambiguity. Once a crater forms, how can one tell whether the rock that caused it was local or interstellar? The evidence may be buried in chemistry and isotopes, in elemental fingerprints that do not match solar system norms. A handful of meteorites found on Earth already carry peculiar signatures, oxygen isotope ratios that do not fit familiar patterns. Could they be fragments of alien systems, shards of other suns that landed here unnoticed? The question remains open, but there is a deeper possibility, one more profound than violence. Interstellar projectiles could carry life's ingredients. The theory of panspermia suggests that microscopic organisms, or at least the complex molecules that form them, may travel across space embedded in rock or ice. Shielded from radiation deep within a fragment, these molecules could survive journeys of millions of years. When such a body strikes a planet, it could seed the surface with chemistry alien yet compatible, nudging the spark of biology forward. In this light, interstellar impacts are not only risks, but opportunities. Earth's early oceans, rich in chemistry, may have been seeded by countless comets. If some of those comets were interstellar, then life itself may be a galactic phenomenon, carried from system to system not by intention but by chance. Every world struck becomes a potential laboratory for biology. Every fragment flung into exile becomes a messenger of possibility. The idea is both exhilarating and unsettling. If life can spread this way, then the galaxy may be full of living worlds, seeded not once but many times, interconnected by the silent exchange of matter. But if this is true, then impacts are double-edged. For just as they may bring life, they may also extinguish it. A large interstellar impactor striking Earth today would unleash an energy capable of leveling continents, boiling seas, or plunging the atmosphere into darkness. The extinction of the dinosaurs was likely caused by a local asteroid just 10 kilometers wide. An interstellar fragment of similar size, moving even faster, would be more devastating still. This is the existential risk, that somewhere in the endless flux of fragments, a traveller exists whose trajectory intersects ours not in passing but in collision. The probability may be low in any given year, but over millions of years, certainty grows. Earth's history of mass extinctions reminds Riaz that cosmic violence is not a matter of if, but when. The only question is the origin of the next stone. Will it be a native shard or a stranger from the stars? The search for answers continues. Scientists analyse meteorites, searching for chemical signatures beyond the solar system. They model trajectories of hyperbolic bodies, calculating how often such fragments should strike. Some argue that the Chicxulub impactor itself, the stone that ended the age of dinosaurs, might even have been interstellar. The evidence is inconclusive, but the possibility remains that an alien fragment once rewrote the history of Earth, clearing the way for mammals and ultimately for humans. If true, then humanity itself may owe its existence to an interstellar catastrophe. Life's fragility and resilience are bound to the same coin tossed across time by chance impacts. Creation and destruction are inseparable. The same cosmic violence that can end worlds may also give birth to new beginnings. Philosophically, this recognition reshapes humanity's relationship with the stars. We are not only the children of our sun, we are heirs to a galactic story, shaped by fragments from beyond, vulnerable to strangers that cross our skies unseen. Earth's history is not a closed narrative, but part of a larger exchange, a cycle of exile and encounter, of stone and chemistry migrating endlessly between systems. And now, as Atlas drifts toward the asteroid belt, the question is sharpened by presence. Will this interstellar visitor survive to continue its exile? Or will it meet its end among the ruins of unfinished worlds, leaving behind fragments that one day may drift inward, perhaps even striking Earth? If so, then Atlas would join the long and hidden history of interstellar impacts, contributing once more to the cycle of destruction and creation. Every crater, every extinction, every emergence of new life is a reminder. The universe does not separate beginnings from endings. They are the same process, seen from different perspectives. Interstellar projectiles embody this truth. They can extinguish the old while carrying the seeds of the new. And so the history of impacts is not only geological, it is existential, philosophical, even biological. To ask whether Earth bears scars from interstellar stones is to ask whether life itself, our own life, was born of such encounters. Did we arise because of them or despite them? And in the deep future, will we fall to them as other species have before? In the silence of space, Atlas continues its path, fragile, faint, a shard of another sun. If it collides, it will write a new scar into the record of worlds. If it survives, it will carry its chemistry onward into the outer dark. Either way, it is part of the same history, the endless exchange of matter, the endless cycle of seeding and extinguishing, the endless truth that in the cosmos, nothing is isolated, and nothing is permanent. The Earth beneath us may already hold the dust of alien stars, and if so it be, then humanity itself is the legacy of interstellar impact, born not only of this world, but of countless others. The night sky appears eternal to the human eye, unchanging, still, infinite, but through the lens of modern observatories it becomes a place of motion. Stars tremble with parallax, asteroids drift faintly against the background, comets ignite with the sun's warmth. And among these patterns of movement, the rarest of all emerge, the interstellar visitors, fragments of alien systems slipping briefly into view. To see them requires vigilance, patience, and instruments designed to trace even the faintest flicker of light. 3 guardians now stand watch over the heavens, Pan-STARRS, Atlas, and soon the Vera Rubin Observatory. Each is a sentinel, tasked not with gazing at distant galaxies, but with protecting the solar system from its most immediate mysteries. Together, they form a net cast across the dark, delicate, but wide enough to catch travellers like 3-Eye Atlas. Pan-STARRS, perched on Haleakala in Hawaii, was the first to glimpse Oumuamua in 2017. Its wide-field cameras scan immense swaths of the sky each night, comparing images for the faintest sign of motion. Its discovery of that elongated shard of alien stone reshaped astronomy overnight, proving interstellar wanderers were not fantasy, but fact. Pan-STARRS showed what was possible, that with enough patience and automation the galaxy's whispers could be heard. Atlas, stationed across Hawaii, and now expanding to Chile and South Africa, was designed with another purpose: to defend. Its acronym, Asteroid Terrestrial Impact Alert System, is a reminder of humanity's vulnerability. Built to identify small asteroids on collision courses with Earth, Atlas scans the sky every 2 nights. It is not the largest nor the most powerful, but it is relentless. It was here that 3-Eye Atlas was found, an object so faint and so fragile that only constant vigilance revealed it. A system built to guard against local threats had stumbled upon a messenger from another star, and soon the greatest of them all will rise in Chile. The Vera Rubin Observatory, home to the Legacy Survey of Space and Time, LSST. With its 8.4-metre mirror and 3.2 gigapixel camera, Rubin will map the entire visible sky every few nights, building a movie of the heavens in motion. Where Pan-STARRS saw one and Atlas saw another, Rubin is expected to see dozens, perhaps hundreds of interstellar objects each decade. It will reveal not exceptions but a population, turning anecdote into science, rarity into pattern. So, these telescopes do more than detect, they calculate. From faint light they derive trajectories, reconstructing the arcs of stones across the solar system. By tracing those arcs backward, astronomers can glimpse where such visitors came from. By tracing them forward, they can ask whether survival is possible. For 3-Eye Atlas, its faintness complicates the task. Its light curves shift unpredictably, as though it were breaking apart even as it is observed. And yet, even in fragility, its orbit can be drawn, a hyperbolic path, unbound to the sun, carrying it through the asteroid belt past Jupiter and outward into the dark. Whether it survives that journey is uncertain, but the mathematics is clear. Atlas does not stay. Its time with us is brief, a passage measured in months, not centuries. The telescopes offer more than positions. They whisper of composition. By splitting the light into spectra, astronomers search for fingerprints of minerals, ices and dust. With Borisov, such fingerprints revealed an abundance of carbon monoxide, hinting at a cold alien nursery. With Oumuamua, the spectra showed little, deepening its mystery. With Atlas, the signals are faint but suggest fragility, perhaps ice-rich, perhaps more rubble pile than stone. And in this fragility lies the central question: survival. The telescopes have seen comets disintegrate near the sun, asteroids shatter after close approaches, and even fragments collide and vanish into dust. Atlas may follow the same path. Observatories will trace its brightness as it dims, watching for sudden drops that signal collapse. If it fades too quickly, it will mean disintegration. If it remains steady, it may yet endure. For humanity, these instruments are more than machines. They are extensions of perception. Where the human eye sees permanence, telescopes reveal motion. Where the eye sees darkness, telescopes reveal faint points of light, each carrying the story of its origin. And where the human mind imagines isolation, telescopes reveal connection, the flow of fragments between stars, the passage of travellers like Atlas. In the coming years, as Rubin begins its survey, the floodgates will open. What was once rare will become common. Each night, algorithms will sift through terabytes of data, highlighting moving points invisible to human eyes. Among them will be local asteroids, comets, satellites, even space debris. But within that torrent, there will also be strangers, bodies on hyperbolic paths, visitors from beyond, each carrying with it a piece of the galaxy's greater story. With every detection, astronomy steps closer to understanding. The trajectories reveal not only where these bodies are going, but hint at the forces that shape them. Close encounters with giants, collisions, migrations. The brightness curves reveal not only rotation, but fragility, structure, and decay. Together, they transform the faint points of light into history books, written in motion and reflection. As Atlas drifts toward the asteroid belt, telescopes across Earth continue to follow. They know its time is limited, that soon it will fade beyond reach, but even brief encounters matter. Each observation adds to the mosaic, helping humanity understand not just this one traveller, but the population it represents. And there lies the wisdom of vigilance. To see is to know, and to know is to prepare. By watching the faintest visitors, humanity learns not only about other worlds, but about its own place among them. The telescopes on the watch remind us that we are not separate from the galaxy, but immersed in it, part of its currents, subject to its fragments. Pan-stars opened the door. Atlas showed what vigilance can reveal. Rubin will unveil the tide itself. Together they form humanity's eyes on the galactic ocean, watching for travellers, fragile and fleeting, who pass through the solar system carrying the memory of stars we may never see. And tonight, those eyes are fixed upon a single dim point, 3i Atlas, fragile stranger drifting toward the perilous belt. In the darkness between stars, it is easy to imagine that a wandering body is safe. The void feels infinite, the distance is immeasurable, the emptiness complete. Yet space is not a sanctuary, it is a crucible. It is a place where the smallest forces, repeated endlessly, can undo even the most ancient travellers. For objects like 3i Atlas, fragility is not the exception, it is the rule. The first enemy is solar radiation. The sun may be a single star among billions, but its furnace radiates power across billions of kilometres. As Atlas drifts through the inner solar system, it is bathed in streams of photons. Each carries momentum. Each delivers a push so faint it cannot be felt by human skin, but over months and years it can change trajectories, alter spins, destabilize fragile structures. This pressure of light, called radiation pressure, has already been suggested as one of the causes of Oumuamua's strange acceleration. For a porous, delicate fragment like Atlas, radiation pressure could be not just a nudge, but a fracture, tugging unevenly across its surface, amplifying weaknesses until cracks spread like veins of ice in winter. Beneath radiation lies the subtler danger of thermal stress. As Atlas rotates, one side warms in sunlight while the other cools in darkness. Minute expansions and contractions ripple through its material, opening fissures, peeling away layers, loosening dust. If it carries volatile ices, sunlight can drive sublimation, jets of vapour bursting from its surface, spinning it faster, pushing it off course, eroding it from within. A fragile body may not survive this duel of fire and ice. Many comets disintegrate near the sun, undone by the very star that illuminates them. Atlas may be no different. Beyond radiation, there are the invisible hands of gravitational tides. Every mass curves spacetime, and when a small body passes near a larger one, the differences in pull across its length can stretch it, strain it, tear it apart. Comet Shoemaker Levy 9 was shattered into fragments by Jupiter's tides before plunging into the giant's atmosphere. Atlas, though passing farther from Jupiter, is no less vulnerable to tidal stresses. Even smaller encounters, with Mars with large asteroids, could leave it fractured. Gravity does not need to capture a body to destroy it. It need only pull unevenly, cracking fragile structures that cannot withstand the strain. And then there are collisions, the silent violence of space. The asteroid belt may be vast and mostly empty, but fragments do collide. Even a pebble at interstellar speeds is a weapon, carrying enough energy to excavate craters or split weak structures. Dust, as small as grains of smoke, strikes with the force of bullets when multiplied by tens of kilometers per second. Over millennia, collisions grind wanderers into fragments. For Atlas, moving quickly and unseen through a debris field, one strike may be enough to end its story instantly. This fragility is not unique. Oumuamua, elongated and tumbling, was suspected by some to be a fragment of a larger body, already shaped by collisions or tidal disruptions before it reached us. Borisov, more comet-like, shed mass visibly, releasing streams of gas until it grew faint. Its nucleus perhaps eroded to almost nothing. Interstellar wanderers do not arrive pristine. They are survivors of ancient violence, already weakened, already cracked. Their passage through a new system is not always endurance, but often the final chapter of a long dissolution. Why then do so many disintegrate before revealing their secrets? The answer lies in time. To cross the galaxy takes millions, sometimes billions of years. No fragment remains unscathed. Radiation from countless stars, collisions with interstellar dust, gravitational nudges from unseen encounters. Each traveller carries wounds long before it enters our skies. By the time it arrives, it may be little more than rubble held loosely together, a ghost of a world long gone. The solar system does not so much destroy them as complete the process already underway. For astronomers, this fragility is both frustration and revelation. Frustration because fragile bodies vanish just as curiosity begins. Instruments are turned toward them only to watch them fade. What secrets they carried, their chemistry, their structure, their origins, may be lost forever in a cloud of dust. But revelation too, because their fragility teaches about their past. A body that unravels tells us it was porous, icy, delicate. A body that fractures under sunlight that reveals its volatile heart. Even in destruction they speak. Philosophically, the fragility of wanderers like Atlas reflects the fragility of existence itself. To move through the universe is to risk unraveling. Nothing endures unchanged. Stars consume themselves. Planets erode, so civilizations rise and fall. Atlas is no different. It carries the memory of survival across eons, yet survival is always temporary. Its fragility is not failure. It is truth. And yet, fragility can be luminous. A comet that disintegrates paints the sky with brilliance, a tail stretching across darkness, a reminder that impermanence can also inspire wonder. If Atlas shatters, it will leave not silence but memory, a brief light across telescopes, a record etched in mathematics, a metaphor inscribed in human imagination. Fragility does not erase meaning, it deepens it. So Atlas continues, a traveller in a universe that offers no sanctuary. It may endure, it may fracture, it may dissolve, but in its fragility, it reveals a lesson. That the void is not empty, that survival is never certain, and that every story is written against the possibility of silence. To watch Atlas risk disintegration is to glimpse not only the peril of wanderers, but the condition of all things. Fragility is universal, yet so is endurance, however brief. Even if destroyed, Atlas reminds us that existence itself is a fragile crossing, a luminous passage through a dangerous and infinite dark. Before Atlas, before Borisov, there was a first. In the autumn of 2017, a faint point of light swept through the solar system. At first, it was catalogued as a comet, then as an asteroid, before astronomers realized it was something entirely new. The first recorded interstellar object, given the Hawaiian name Oumuamua, a messenger from afar arriving first. What it revealed was not comfort, but confusion. Oumuamua did not behave as it should. Its orbit was hyperbolic, proving it had come from beyond. Its shape, inferred from the way its brightness fluctuated, appeared extreme, perhaps elongated like a shard, 200 meters long but only a fraction as wide. Some speculated it could be disc-like instead, flattened like a fragment of foil. Either way, it was unlike any asteroid or comet known in the solar system. And then came the greatest surprise. As it receded from the sun, it accelerated. Not dramatically, but measurably. The mathematics did not lie. Something was pushing it, gently but undeniably. away from the sun faster than gravity alone could explain. For a comet, such acceleration would be expected. Outgassing, jets of vapour from sublimating ice, acts like thrusters, nudging the body slightly. But Oumuamua showed no tail, no coma, no visible evidence of gas. Its surface appeared inert, its brightness clean and sharp. The push was there, but the cause was hidden. Speculation erupted. Some argued the outgassing was present, but too faint to see, perhaps composed of hydrogen sublimating invisibly. Others suggested its shape, so thin or so elongated, meant sunlight itself could push it through radiation pressure, like a cosmic sail. More radical voices asked if it could be artificial, a fragment of technology cast adrift. The debate remains unresolved. Oumuamua departed too quickly for answers. By the time telescopes turned to it, its best moment had already passed. What remains is not certainty, but mystery, and that mystery is crucial for understanding Atlas. Oumuamua taught astronomers humility. It showed that interstellar objects will not conform to solar system categories. They may not look like comets, they may not behave like asteroids, their physics may contain surprises that defy prediction. Atlas therefore cannot be judged by Earth's familiar standards. Its faintness, its fragility, its unpredictable light curve, each may conceal processes not yet understood. The acceleration of Oumuamua also sharpened the sense of fragility. If radiation pressure could move it, then it must have been thin, perhaps a mere sheet of material. If outgassing was the cause, then it must have been riddled with ices that released vapour in silence. In either case, it was vulnerable, temporary, delicate. The same may be true of Atlas. Its path through the solar system could be altered not only by gravity, but by forces hidden, subtle, emerging from within its own structure. Astronomers speculate. If Oumuamua could survive passage near the Sun despite its fragility, could Atlas survive the asteroid belt despite its instability? If hidden jets can push Oumuamua, could unseen outgassing destabilize Atlas into disintegration? Each question echoes the lesson. Interstellar visitors are not predictable. They are messengers, but their messages are ambiguous, their language strange. Oumuamua also reshaped science's readiness. Its sudden appearance revealed how unprepared humanity was to capture such fleeting events. By the time telescopes tracked its acceleration, it was already vanishing into the dark. With Atlas, astronomers are more vigilant, racing to gather data before it disappears. The lesson of Oumuamua was urgency. Interstellar visitors do not wait. They arrive, they confound, and they depart. Philosophically, Oumuamua whispered something deeper. It reminded humanity that the galaxy is filled with strangeness beyond current comprehension. A single shard no larger than a skyscraper disrupted centuries of assumptions about comets, asteroids, and motion itself. It forced scientists to accept uncertainty, not as failure, but as the beginning of understanding. For Atlas, the lesson is sobering. It too may defy categories. It too may reveal behaviours that do not fit models. Already its fragility suggests it is no ordinary rock. Already its faintness challenges observation. If it survives, it may carry scars of forces unseen. If it shatters, it may teach us that survival itself is rare among such wanderers. Oumuamua departed without answering its mysteries. Its acceleration remains unexplained, its shape unknown, its chemistry uncertain. But what it left behind was a change in perspective. Humanity now knows to expect the unexpected, to watch every faint glimmer carefully, to prepare for ambiguity. In this way, Oumuamua continues to guide us. Its strangeness illuminates Atlas's fragility. Its mystery warns us of Atlas's fate, for both are messengers, and both remind us that the galaxy does not yield its secrets easily. As Atlas drifts toward the asteroid belt, its light flickering faintly, astronomers recall the lessons of the first. Be vigilant, be humble, expect the unknown, and above all remember, in every visitor there is not only science, but wonder. If Oumuamua was mystery, silent, strange, unyielding, then the second interstellar visitor, Borisov, was revelation. Discovered in August 2019 by amateur astronomer Gennady Borisov, its nature was unmistakable. Unlike the enigmatic shard that preceded it, Borisov looked like a comet. a nucleus wrapped in a pale envelope of gas and dust shedding a long tail in the direction of the sun. It was familiar, almost comforting, a body behaving in ways astronomers understood, and yet it was also alien, because it was not ours. For the first time, humanity witnessed a comet born beneath another star. Its chemistry told the story. Through the eyes of the Hubble Space Telescope and spectrographs on Earth, Borisov revealed itself to be volatile rich, brimming with carbon monoxide. The concentration was far higher than most comets in the solar system. This suggested a birthplace in the outer reaches of its native system, where the cold was intense enough to preserve such fragile ices. Borisov was not just a comet, it was a relic of an alien nursery, a frozen archive of conditions far from our sun. But Borisov was also fragile. Its nucleus, only a kilometre or two across, showed signs of instability from the start. As it neared perihelion, sunlight awoke its buried ices, driving jets that fractured its crust and blurred its structure. By 2020, Hubble images revealed it was disintegrating, its body breaking apart, dissolving into a diffuse cloud of dust. The comet survived its passage, but in pieces, fading into invisibility as it drifted outward once more. Borisov's fate is more than a footnote, it is a warning. For Atlas too appears fragile. Its brightness variations suggest instability, its faintness hints at weakness, its path uncertain. If Borisov, larger and more coherent, could unravel under the sun's touch, what chance does a smaller, dimmer object like Atlas truly have? The comparison is haunting. Oumuamua endured, but in strangeness, its resilience unexplained. Borisov behaved like a comet, but perished in that very familiarity. Atlas now seems to carry pieces of both legacies. The fragility of Borisov, the ambiguity of Oumuamua. It may be too delicate to endure the asteroid belt, too volatile to remain whole, too faint to reveal its true composition before it is gone. And yet, Borisov offered lessons beyond fragility. In its chemistry, astronomers glimpsed the diversity of planetary systems. Its richness in carbon monoxide suggested an environment colder than ours where ices never sublimated. This proved that comets can vary dramatically between stars. Some are volatile rich, others depleted, their composition sculpted by suns unlike the sun. Borisov was not just a visitor, it was a sample, freely delivered from an alien laboratory. Atlas, if it survives long enough to be studied, may tell a different story. Perhaps it is poor in volatiles, more asteroid than comet. Perhaps its fragility is structural, a rubble pile rather than a solid body. Each interstellar object adds a chapter to the growing catalogue of diversity, revealing that planetary formation is not a uniform process but a spectrum of possibilities, each star writing its own script. The ghost of Borisov lingers in another way, in its impermanence, for even as astronomers observed it, they knew it would not last. It was dissolving before their eyes, a comet unravelling in real time. To watch it fade was to be reminded that interstellar visitors are transient by nature. They do not stay, they do not return, and their presence is fleeting and their lessons must be seized before they vanish. This impermanence mirrors Atlas itself. Already its faintness makes it elusive. Already its structural weakness hints at disintegration. Perhaps it will endure long enough to cross the asteroid belt. Perhaps it will not. If it does, it may carry Borisov's legacy, a body diminished, fading into fragments. If it does not, then like Borisov, its end will be transformation, its dust absorbed into the solar system it briefly entered. But within that transformation lies meaning. Borisov, in dissolving, left behind more than dust. It left a realization that alien comets are not abstractions but realities, accessible to observation. It proved that interstellar chemistry could be studied, that alien ices could be sampled by telescope. In its fragility, it gave science a gift even as it perished. Atlas may follow the same path. Its demise, if it comes, will not be failure but revelation. For every disintegration is an opportunity. The fragments scatter, revealing the composition of the whole. The dust brightens, making faint bodies visible. To perish is to reveal Yako, and in revealing to teach. Thus Borisov remains a ghost not because it vanished, but because it lingers, in memory, in data, in the lessons it left behind. And as Atlas drifts closer to the belt, astronomers watch with the same vigilance, aware that fragility is not loss, but knowledge waiting to emerge. Oumuamua taught mystery. Borisov taught fragility. Together they form the twin warnings that frame Atlas's fate. Expect the unknown and prepare for impermanence. For interstellar, objects are not monuments. They are whispers carried on cosmic winds, fading as quickly as they arrive. Borisov has already returned to silence. Dissolved into invisibility, Atlas may soon follow, but in that fading lies the essence of their message, that the galaxy does not endure in permanence, but in fleeting exchanges, in brief moments of encounter, in fragile visitors who pass through and then are gone, and in their passing, they leave us changed. The orbit of 3i Atlas now carries it toward the solar system's ancient boundary of stone. Between Mars and Jupiter lies a field not of emptiness, but of memory. The asteroid belt, millions of fragments circling in silence. To pass through is not to weave among a crowd of boulders, as films so often imagine, but to thread a region both spacious and dangerous, where emptiness dominates, yet hazard remains. For a traveller as fragile as Atlas, survival is a matter of statistics, of probabilities hidden within the mathematics of celestial mechanics. The numbers tell part of the story. The asteroid belt contains more than 1 million bodies larger than a kilometre, and countless more the size of mountains, hills or dust grains. Yet the belt itself is vast, stretching hundreds of millions of kilometres across. On average, any given asteroid is separated from its nearest neighbour by nearly 1 million kilometres. A visitor like Atlas could, in principle, sail through without approaching within tens of thousands of kilometres of even the largest members. The void still dominates, but chance is never absent. Small fragments, unseen even by the most vigilant telescopes, drift invisibly in that domain. Meteoroids no larger than boulders can strike at hypervelocity. For Atlas, weak, unstable, already trembling with fractures, even the faintest collision could mean disintegration. Astronomers turn to simulations. By running millions of virtual trajectories through the belt, they test the odds of survival. Most models show that interstellar bodies face only a minor chance of direct impact, a fraction of a percent, but survival is not only about avoiding collision. The subtle tug of nearby asteroids, the gravitational pull of Ceres or Vesta, can alter a path in ways difficult to predict. A single encounter, even without contact, could stretch an orbit or increase its rotation. For a fragile body, spin is deadly. Internal stresses can tear it apart from within. Jupiter too is a silent presence. Its mass governs the architecture of the belt, shaping resonances that stir instability. Even distant, its influence can bend a path subtly, changing a safe passage into a spiral of disintegration. In simulations, many trajectories show Atlas emerging beyond the belt intact, but altered. Its rotation quickened, its structure weakened, its fragments loosened. Survival then may mean endurance in pieces rather than as a whole, and yet statistics whisper hope. For every comet that has crossed the belt before, for every fragment that has slipped inward from the Oort cloud and returned outward again, most survive. Comets may fragment, but many endure. Meteor showers on Earth, formed from the trails of such survivors, prove their passage. The belt, though dangerous, is not impassable. It is a crucible, not a wall. Still, Atlas is not a comet of our own. It may not have the cohesion of a local body. Its exile has been long, its journey harsh. Radiation, micrometeoroid bombardment, the stress of countless gravitational tides, these may already have left it brittle. For such a traveller, the belt is not only chance but trial. Its survival odds may be lower than those of native comets. The simulations also suggest unseen dangers. Dust clouds, relics of past collisions drifting through the belt. These are invisible at great distance, yet dense enough that a fragile traveller could be scoured, eroded into fragments. Unlike collisions with large bodies, such encounters would leave no crater, no obvious scar, only dissolution, a fading into dust too faint to follow. Astronomers know they may never learn the outcome. Atlas is faint, difficult to track. If its light vanishes suddenly, was it destroyed by collision, by self-fragmentation, or simply by distance and dimness? The statistics cannot answer. They can only suggest, whispering probabilities that lean towards survival but never guarantee it. And so the crossing becomes a meditation on chance itself. Every fragment in the belt is a survivor of planetary birth that failed. Every stone carries the memory of an outcome never reached. Atlas, born of another star, now risks joining them, not by design but by chance encounter. The numbers may favour endurance, but statistics are cold comfort for a fragile traveller. One stone in a million is enough to erase its story forever. If it emerges, it will carry the marks of the belt, perhaps unseen, but present. A shift in spin, a fracture widened, a surface dusted with grains from passing encounters. Its trajectory will tell the tale, altered slightly, bent by subtle encounters, yet still carrying it outward, toward the gas giants and the edge of the system. Survival will mean not invulnerability, but persistence through subtle ruin. If it perishes, the belt will absorb it silently. Its fragments will scatter, becoming part of the archive of the unfinished worlds. Perhaps centuries from now, a spacecraft exploring the region will encounter grains of dust that once belonged to Atlas, never knowing the history they carried. In such a fate, its story would not vanish. It would merge with ours, becoming part of the solar system it only briefly visited. The statistics of survival remind us of fragility. They remind us that in the vastness of space, even emptiness is dangerous. They remind us that exile is not only about distance, but about risk. Atlas carries not just the chemistry of another star, but the precariousness of all wandering things. To cross the asteroid belt is to trust chance, to surrender to probabilities written in the mathematics of motion. The belt does not choose who survives. It does not favour the native or the foreign. It only orbits endlessly, circling the sun, indifferent to the fates of those who pass. For Atlas, the crossing is both peril and possibility. If it endures, it will emerge altered, scarred, but still a messenger from the stars. If it perishes, its dust will remain, woven into the debris of this unfinished world. In either case, the belt writes its story into the archive of time, another fragment added to the endless ledger of survival and loss. The statistics may lean towards survival, but statistics are abstractions. For Atlas, there is no probability, only outcome. One path, one fate, one truth decided in silence among the ancient stones. If Three-Eye Atlas meets its end, it will not be in fire or thunder. There will be no sound, no shockwave to carry across the void. The violence of space is silent. Collisions unfold in absolute quiet, their energy is immense yet unaccompanied by any echo. On Earth, an impact is sound embodied. The air shakes, the ground trembles, waves of pressure roll outward. But in space there is no air, no mediums to carry a noise. When stones strike at tens of kilometers per second, they release energies equivalent to nuclear weapons, yet the event is mute. Only light and motion betray the violence, flashes invisible across distance, fragments scattering into trajectories that no human eye will follow. If Atlas collides with a fragment of the asteroid belt, the destruction will be instant. At relative velocities of 20, 30, even 50 kilometers per second, the kinetic energy is overwhelming. A stone the size of a boulder could erase Atlas in a heartbeat, vaporizing part of its structure, hurling the rest into dust. Yet to the solar system, the event would pass unnoticed. The belt has seen such collisions for billions of years. Entire asteroids have been shattered, their fragments dispersed into families. Atlas would be only another in an endless sequence of silent destructions. Astronomers would likely never see it. Its faint light would simply vanish from their measurements. One night the point would be present, the next it would be gone. They would search, recalibrate, try to trace its trajectory, but the truth would be lost in silence. The traveller struck, destroyed, erased without witness. There is something haunting in this quiet. On Earth, violence is spectacle. In the cosmos, violence is absence. Destruction leaves no sound, no cry. It leaves only absence, the vanishing of what once was, the sudden silence of a light gone dark. And yet the silence does not mean insignificance. Every impact writes itself into matter. The fragments of Atlas, if shattered, would scatter across the belt, orbiting the sun for ages to come. Dust would mingle with native debris, a fusion of alien and local histories. The destruction would not be meaningless. It would be transformation, memory absorbed into new forms. Silence conceals meaning, but it does not erase it. The asteroid belt itself is a graveyard of silent impacts. Craters mark Ceres, Vesta, and countless smaller bodies. Each scar was made without sound, each collision reshaping matter in mute violence. Over billions of years, the belt has been sculpted not by slow erosion, but by sudden silent catastrophes. To cross it is to pass through a mausoleum of unvoiced impacts. For Atlas, survival is uncertain. Its fragility makes silence more likely. Even without a collision, internal stresses may tear it apart. Outgassing, spin, or the pull of Jupiter could unravel it, scattering fragments invisibly. This too would be a silent impact, not against stone but against itself, a body collapsing under its own fragility, vanishing without announcement. And so humanity must confront the nature of cosmic violence. It is not dramatic, not thunderous, not theatrical. It is patient, indifferent, and above all silent. When worlds end, when moons shatter, when fragments collide, the universe does not roar. It does not warn, it does not mourn, it simply continues. The great silence of impacts reflects something deeper, that the cosmos does not share human senses. Sound is an earthly phenomenon, a byproduct of atmosphere and pressure. In the void, there is no ear to hear, no medium to carry the wave. The universe is not mute, it is simply speaking in another language, one of motion, light, and gravity. To hear it, humanity must learn to see differently, to measure trajectories, to trace spectra, to listen with telescopes rather than ears. In this silence lies a paradox. Collisions may pass unseen, yet their consequences echo across time. The impact that ended the dinosaurs was salient in the cosmic sense, but its aftermath reshaped the Earth, altering the course of life. If Atlas collides, we may never witness it, but the fragments will endure, their paths altered, their dust drifting through the solar system for ages. Silence conceals the act, but it cannot conceal the legacy. And so the meditation becomes philosophical. Perhaps silence itself is the universe's truth, not absence, but stillness. The cosmos does not narrate its violence. It does not explain, justify, or announce. It simply allows events to unfold, leaving their consequences as testimony. Impacts echo not in sound, but in the survival of fragments, in the scars of craters, in the altered courses of worlds. Atlas drifts forward, fragile, uncertain. If it meets its end in the belt, no one will hear. No one will see the moment. Its passing will be marked only by silence, the disappearance of light, the cessation of a trajectory. And yet, in that silence, it will still speak. Its fragments will tell the story of exile, of fragility, of encounter, of transformation. The great silence of impacts is not emptiness. It is the language of the universe, a language of motion and memory, written in the orbits of dust and stone. To listen is not to hear, but to observe, and in observing, to understand that even silence contains meaning. Thus Atlas faces the belt not only as a crucible of stone, but as a crucible of silence. Whatever its fate, survival or destruction, it will not cry out. It will simply vanish or continue, leaving humanity to ponder the quiet violence that shapes not only this traveller, but every world in the cosmos. In the end, the universe does not roar, it whispers, and in the stillness of that whisper, everything changes. If 3i Atlas survives, its journey will not end in the asteroid belt. Survival would mark only a threshold, a passage through peril into a broader exile. For beyond the belt lies a road long and dark, stretching outward past the giant planets through the frozen frontier of the Kuiper belt, and into the vast reservoir of comets known as the Oort cloud. Beyond that, freedom, a return to interstellar space, carrying with it the scars of its solar system encounter. But what does survival mean for such a fragile traveller? It is not the absence of damage. In the cosmos, survival often means transformation. If Atlas endures, it may emerge altered, spun faster by gravitational nudges, fractured into the clusters of fragments bound loosely together, or carrying scars etched by collisions too small to detect. Its survival will be a survival in pieces, yet still enough to continue outward. Astronomers propose several theories of endurance. One rests in probability itself. The asteroid belt, though rich in fragments, is dominated by emptiness. Most travellers pass through without striking anything. Atlas may follow the same fate, a clean passage through a graveyard of unfinished worlds, emerging intact into the outer regions. This is the simplest theory, that survival requires no miracle, only the statistics of emptiness. Another theory imagines resilience hidden within fragility. Atlas may appear unstable, dim on the edge of breaking apart, yet it may hold together by internal cohesion. Some comets survive perihelion passes far closer to the Sun than expected, their icy cores enduring stresses that models predict should destroy them. Perhaps Atlas carries within it a strength unseen, forged in the violence of its ejection from another system. If it survived that primordial exile, it may yet survive this solar system's trial. A third theory envisions fragmented survival. Atlas may not emerge as one body, but as many. Like Borisov, which shed dust and gas until its nucleus grew faint, Atlas may fracture into smaller shards, each following similar orbits outward. In this sense, its survival would not be singular, but plural, its identity scattered, but its matter still enduring, its chemistry still carried into the galaxy. And finally, there is the most poetic theory that survival itself may be irrelevant. Even if Atlas disintegrates, its dust will survive, mingling with the solar system's debris, orbiting for millennia, drifting outward. In this way, the traveller's survival is not measured in wholeness, but in legacy. What endures is not the object itself, but the influence it leaves behind. If Atlas does survive intact, what awaits beyond? Its trajectory, already hyperbolic, will carry it outward, back into the galactic dark. Its course will be bent slightly by the pull of Jupiter, perhaps altered subtly by Saturn, but nothing will bind it. No planet will capture it. The Sun itself cannot hold it. Once free of the outer system, it will continue unimpeded for millions of years, a wanderer once more, and it will not return. Interstellar visitors do not circle back. They pass through once, then depart forever. If Atlas survives, it will carry with it the memory of encounter, a body marked by our Sun, scarred by our asteroid belt, perhaps altered by faint collisions. It will continue outward, a fragment of another world now bearing the fingerprints of ours. Philosophers and scientists alike reflect on what such survival means. It suggests that the galaxy is not only full of wanderers, but full of exchanges. Every interstellar object that enters a new system acquires new scars, new chemical traces, new histories. Over millions of years, they become composite messengers, carrying the fingerprints of many stars. If Atlas endures, it may one day drift into another system, another set of planets, another intelligent gaze. There, it would no longer be only a fragment of its birth system, but a fragment of many. This possibility ties survival to a grander narrative, the circulation of matter across the galaxy. Planets give birth to fragments, fragments wander, fragments survive, fragments carry. In time, they may seed worlds with dust, organics, even life. Survival is not just endurance, but participation in the greater flow of galactic history. What Atlas carries outward is more than stone and ice. It carries wisdom, not conscious wisdom, but cosmic wisdom, the wisdom of fragility, of endurance, of transformation. Its body is a record of its trials, a logbook written in fractures and brightness curves. To pass through our system and emerge beyond is to add another chapter to that record. Astronomers may never see the scars, but they will know they exist, etched invisibly into its form. There is also humility in the theories of survival. They remind us that endurance is relative. To survive one danger is not to escape all. Even if Atlas clears the asteroid belt, it faces the gravity of the giants, the radiation of the Sun, the micrometeoroid dust of the outer regions. Beyond that, interstellar space itself is no haven. Cosmic rays, stellar encounters, and eons of collisions will continue to erode it. No body is eternal. Survival is always temporary, always provisional, always fragile. And yet, even temporary survival matters. For survival is opportunity, the chance to continue carrying, to continue whispering across the galaxy. If Atlas emerges intact and departs, it will not vanish into meaninglessness. It will remain faint, unobserved, but real. A traveller once touched by our Sun, now moving into the archives of the galaxy. The theories of survival, then, are not just predictions of fate. They are reflections of the cosmos itself, fragility and endurance, loss and persistence, destruction and legacy. These are not opposites, but complements. For Atlas, survival may mean wholeness or fragmentation, or even dust. In all cases, it continues. If it clears the belt, it will fade from our sight, its light will dim, its trajectory grow impossible to trace, and yet in imagination it will endure. carrying scars of stone, whispers of sunlight, fragments of memory from a brief encounter with our system. It will travel into the silence, not erased but transformed, another wanderer among countless others in the galactic sea, and perhaps, somewhere, another set of eyes will one day see it. Another civilization, turning their telescopes to the stars, will notice a faint, irregular light crossing their skies. They will calculate its trajectory and realize it is not theirs. They will call it a stranger, a visitor, a messenger from afar. And in its fractures, its chemistry, its dust, they may glimpse not only the memory of its birth star, but of our sun, our asteroid belt, our brief chapter in its endless journey. Thus, if Atlas survives, it carries forward not only itself, but us. What is 3i Atlas? To astronomers, it is a faint point of light, its brightness diminishing with distance, its orbit traced in numbers. But speculation whispers beyond the mathematics, for in the silence of space, matter is never only stone. Every fragment carries with it the possibility of surprise, the potential to hold within its structure the unseen. Could Atlas itself be more than rock and dust? Could it conceal a cargo stranger, richer, more fragile than science dares to assume? When comets from our own solar system are studied, they reveal treasures. Beneath their crusts of soot and ice lie frozen oceans of possibility, reservoirs of water, carbon, and complex molecules forged in the chemistry of star formation. Missions like Rosetta's encounter with Comet 67P showed that comets carry amino acids, sugars, and other precursors to life. If such richness is common in local comets, then what might a body born under another star contain? Perhaps Atlas carries alien oceans, sealed in ice since the birth of its home system. Water is abundant in the galaxy, forged in stellar nurseries and preserved in comets. Inside Atlas, deep pockets of frozen seas may lie dormant, waiting for warmth to awaken them. If it fragments, those oceans would be released as vapor. Molecules never before seen in our system, their chemistry carrying signatures of alien conditions. Or perhaps it carries something subtler, the chemical seeds of life. The theory of panspermia imagines life spreading not by intention but by accident. Organic molecules hitchhiking across space within comets and asteroids. If Atlas is such a carrier, then within its rubble may lie fragments of alien biology. Not life itself, but the precursors, the scaffolding molecules upon which biology can build. To glimpse those molecules would be to glimpse another possibility for life, a parallel chemistry born in a distant cradle. The speculation stretches further. Atlas may not be uniform at all. It may be a composite, assembled from fragments of larger worlds. In planetary nurseries, collisions between protoplanets can tear apart cores, mantles, crusts. Ejected debris becomes exiles like Atlas, carrying within them the fingerprints of once larger worlds. A shard of mantle rock, rich in silicates, a fragment of core, metallic and dense, a sliver of crust, bearing the imprint of processes now vanished. If Atlas is such a shard, it is not merely a traveller, it is a relic of a lost planet, a messenger carrying the story of a world that never survived. Some speculate even more boldly. What if Atlas is part of a larger system of exchange, interstellar debris fields, drifting archives of planetary formation that link stars together? Perhaps Atlas is one stone among billions, a fragment from a collision that scattered material across light years, each piece carrying alien chemistry to distant systems. If so, then the galaxy itself is an engine of sharing, exchanging material between stars as easily as rivers exchange sediment. And then there is the question of time. Atlas may be older than Earth. If it was ejected billions of years ago, its matter may have circled its parent star before our sun was even born. Its atoms may have witnessed epochs before life stirred in our oceans. Within its minerals may be locked isotopes that speak of stellar conditions long vanished, chemical fingerprints of a galaxy younger than the one we inhabit today. To study Atlas would be to hold in our hands a fragment of galactic prehistory. Speculation also opens philosophical horizons. If Atlas carries organic molecules, or fragments of lost planets, then it is more than a visitor. It is a messenger of connection, a reminder that the galaxy is not composed of isolated systems, but of exchanges. Every star is both a giver and receiver. Every system sheds fragments that may wander into others. Over billions of years, the galaxy becomes an ocean of shared matter, linking worlds that will never meet directly. For humanity, this possibility is profound. If Atlas carries the seeds of life, then perhaps Earth is not unique. Perhaps our oceans, our cells, our very breath carry molecules born beneath another sun. Perhaps the story of life is not confined to Earth, but is a galactic story, written in fragments exchanged silently over eons. But speculation also brings humility. Atlas is faint, fragile, already fading. Humanity may never learn its true nature. Its chemistry may remain hidden, its secrets unmeasured. It may disintegrate before its message can be read, leaving only dust. To imagine frozen oceans or alien molecules within it is to reach beyond certainty, into the poetic realm where science meets wonder. Yet even in that uncertainty lies meaning. For speculation is not fantasy, but the extension of possibility. It is the recognition that the cosmos is richer than any single system, and that every fragment carries more than its surface reveals. If Atlas survives the asteroid belt, it will carry its speculative cargo outward, back into the interstellar dark. It may never reveal its secrets to us, but in imagination it already has. Humanity looks at this faint, fragile visitor and sees more than seeing. It sees oceans locked in ice, molecules of life waiting for warmth, shards of lost planets drifting forever. It sees itself reflected, a world that might just as easily have been a fragment, cast adrift, carrying the seeds of life to strangers far away. The speculative horizons remind us that Atlas is not only an object, but a metaphor. It embodies the possibilities of the galaxy, that stones may carry oceans, that dust may carry life, that fragments may carry wisdom. Its passage through our system is fleeting, but its presence opens doors of thought that stretch far beyond. And so we wonder, could Atlas itself be more than stone? Could it carry within its fragile body the chemistry of alien beginnings? Could it be a shard of a lost world or a messenger of life itself? The answers may never be known, but the questions themselves are a gift. They remind us that the galaxy is alive with possibility, and that every faint light in the sky may carry more than it appears. Atlas drifts forward, silent, fragile, unknown, and in its faint glow, humanity sees not just a stone but horizons of speculation, vast, endless and full of wonder. In the stillness of the cosmos, there is an invisible hand that guides all motion. It does not push, it does not pull, not in the way human senses imagine. It bends, it curves, it reshapes the very stage upon which matter moves. This hand is gravity, and its nature was revealed not by Newton's falling apple, but by Einstein's deeper vision. According to general relativity, space is not empty. It is a fabric, pliable and continuous, curved by the presence of mass and energy. Planets, stars, black holes, each leaves its mark, shaping space-time like stones resting on a stretched sheet. Objects in motion, like Atlas, follow the curves of this fabric. They do not choose their paths. They are guided, threaded along invisible lines sculpted by the masses they encounter. For 3i Atlas, gravity is the quiet architect of its fate. From the moment it crossed the boundary of the solar system, it ceased to move freely. The sun's immense curvature drew it inward, altering its course into a hyperbolic arc. Every planet adds its own subtle pull. Even the asteroids, though small, contribute whispers of deflection. Atlas is not navigating the solar system, it is being navigated by it. Einstein's equations predict this with precision. They tell us how the sun's mass bends light from distant stars, how galaxies act as gravitational lenses, magnifying objects behind them. They also tell us how a fragile visitor like Atlas will thread between hazards not by will, but by geometry. Its orbit is not a line, but a geodesic, the straightest possible path through curved space-time, and in that path lies both peril and survival. A near encounter with Mars, or a grazing pass by Jupiter, could alter its velocity, redirecting it into unexpected courses. A slight deflection may mean the difference between a safe exit into interstellar space and a destructive encounter with another body. Atlas, fragile and unresisting, is at the mercy of the universe's geometry. The subtlety of gravity is astonishing. Consider Jupiter, the giant planet whose mass is 2.5 times that of all the other planets combined. Its curvature of space-time extends like an unseen shield across millions of kilometers. Objects that stray too near may be captured, redirected, or cast out entirely. Jupiter is a gatekeeper. For comets born in the Oort cloud, it often decides their fate, either deflecting them toward the inner planets or hurling them back into the dark. For Atlas, a close approach could shatter its trajectory, spinning it into fragments or scattering it into new orbits. Even light is not immune. Gravity bends photons themselves, curving their paths around stars. During the solar eclipse of 1919, this bending was measured, confirming Einstein's theory and rewriting humanity's understanding of the cosmos. If light itself is bent, how much more fragile is a stone like Atlas, faint and fractured, drifting through these same curvatures? Astronomers watch its orbit carefully, adjusting calculations with each new observation. They know its path is not a perfect line. They know uncertainties grow, that unseen factors, jets of sublimating ice. Collisions with dust or even the Yarkovsky effect of sunlight can alter its trajectory further. But beneath all these subtleties lies the deeper truth. Gravity's invisible hand shapes the stage, and Atlas can only follow. The imagery is almost poetic. Atlas, a shard of another world, does not wander freely. It is a thread drawn across a cosmic loom, weaving briefly through our solar system before continuing outward. Its path is not chance but geometry, written into space-time by Einstein's equations a century ago. In this weaving lies wonder, for it means that the galaxy itself is interconnected not just by material exchange, but by geometry. Every star bends space-time, every planet curves it, every fragment follows. The universe is not chaos. It is a fabric of order, curved but continuous, mysterious but precise. For Atlas, survival may depend on how gently it is guided through this fabric. Too sharp a bend may tear it apart, too near a pass may fracture it, but a smooth geodesic, unbroken, will carry it safely through, threading it between worlds and hazards, guiding it back into exile beyond the sun. Philosophically, Einstein's lens reshapes the way we see this fragile traveller. It is not simply at risk from random chance. It is enacting a journey written into the fabric of space-time itself. Its course is determined by the masses it passes, its future predicted not in choices, but in curvatures. In this sense, Atlas is not unlike humanity. Guided by unseen structures, shaped by forces beyond perception, carried through a universe where destiny and geometry intertwine. And yet within those curvatures, there is room for awe. For though its path is determined, its story is unique. The same equations that guide a comet from our Oort cloud now guide a fragment from another star. The universality of gravity ties them together, uniting alien and familiar under the same law. Atlas drifts onward, following Einstein's lens, its fate inscribed in curves invisible to the eye. If it survives, it will carry with it the marks of that guidance, the scars of a trajectory bent but unbroken. If it perishes, it will perish along those same lines, dissolving into fragments that continue the path geometry demands. Gravity does not choose outcomes, it only shapes them, and in that shaping it threads Atlas between worlds, carrying it through Cernus, carrying it into history, carrying it into the endless exile beyond the sun. In the vastness of space, the great dangers seem obvious: planets, stars, asteroids, the pull of gravity itself. Yet often it is not the giants that claim the fragile, but the smallest of things. The cosmos, though appearing empty, is filled with dust. Grains no larger than smoke, shards no wider than a human hair, drifting endlessly between stars. Invisible to the naked eye, they are the quiet sculptors of eternity. For a traveller like Three-Eye Atlas, fragile and fractured, dust may prove as perilous as stone. Each grain is a remnant of a dying star, atoms forged in supernovae, condensed into tiny silicate or carbon structures set adrift on galactic winds. To encounter them is to collide with history itself, but collisions at cosmic velocities are not gentle. At speeds of tens of kilometers per second, even the smallest grain carries energy enough to chip, fracture, and erode. Over millennia, this grinding becomes decisive. Astronomers calculate that interstellar dust impacts can slowly ablate the surfaces of comets and asteroids, stripping away layers micrometer by micrometer. A single collision is trivial, a billion collisions are transformative. For bodies wandering between stars, the accumulated effect is erosion so deep that what survives after millions of years is often only a fraction of what began. Atlas, already fragile, already trembling with instability, is vulnerable in the extreme. Its faint brightness suggests a body of low cohesion, perhaps a rubble pile, perhaps porous ice and dust barely held together. Dust grains striking such a body would not merely scar the surface, they could penetrate, fracturing internal structures, accelerating disintegration. 1,000 invisible impacts could do what a single asteroid might not: reduce a visitor to untraceable fragments, dissolved into the galactic medium. This fate is not theoretical. Meteorites collected on Earth show microscopic craters, each the scar of a dust impact during their passage through space. The lunar regolith soil on the Moon bears countless pitted marks from micrometeoroids. Dust is relentless. It does not roar, it does not strike with drama, but it endures. In the scale of millennia, it wins. For Atlas, the quantum of dust is both present and future. Within the solar system, the zodiacal cloud of fine particles poses risk. Beyond, the interstellar medium itself is laced with grains. The longer it wanders, the more erosion it suffers. To endure millions of years across the galactic dark is to be ground down, slowly but inexorably, until nothing remains but atoms dispersed into the void. And yet this erosion carries meaning, for even in dissolution, matter does not vanish. The fragments of Atlas, if eroded to dust, will become part of the interstellar medium that feeds the birth of new stars and planets. Dust is not only an end, but a beginning. It is the seedbed of galaxies. The same grains that erode travellers are the grains that coalesce into nebulae, into disks, into worlds. Destruction becomes creation. Loss becomes renewal. Philosophically, the quantum of dust speaks to fragility itself. The universe does not require cataclysms to end stories. It needs only patience. The silent accumulation of the smallest impacts, repeated endlessly, wears down even the grandest travellers. In dust lies the lesson of inevitability, that survival is never absolute, only prolonged. But there is another dimension. Dust is also a carrier. Within its microscopic grains are complex molecules, organics forged in the atmospheres of stars, polycyclic hydrocarbons that may seed the chemistry of life. If Atlas is eroded into dust, then its fragments may carry its alien chemistry into other systems. Ground down, it becomes not less, but more dispersed, spreading its story across the galaxy in particles that may one day fall into alien seas or soils. For scientists, this duality is humbling. Dust is both destroyer and messenger. It erases form but preserves substance. It robs travellers of identity but ensures their atoms endure. For Atlas, to be ground to nothingness is not erasure, but transformation, its alien matter mingling with the same grains that sculpted it in the beginning. In this light, the fate of Atlas mirrors the fate of all things. Stars collapse into remnants, planets erode into fragments. Even galaxies disperse into the background of cosmic expansion. Dust is the common denominator, the smallest scale at which destruction and creation meet. The quantum of dust is not weakness, it is universality. As Atlas moves forward, perhaps it will survive the asteroid belt, perhaps it will survive the giants. But beyond, time itself will unleash its smallest army. Grains of silicate and carbon, unseen but countless, will chip away at its form until only memory remains. And in that memory lies a paradox. Atlas will be gone yet not gone, dissolved yet present, lost yet woven into the fabric of the galaxy. Thus the meditation turns inward. Humanity too is subject to dust. Our monuments erode, our bodies return to Earth. Our stars themselves shed dust as they die. We are shaped by the same process that erodes Atlas. We are dust, and to dust we return. In the end, the greatest enemy of Atlas may not be collision, or gravity, or sunlight. It may be the patient, invisible grinding of dust, quiet, unstoppable, eternal. A force too small to see, yet too persistent to deny. And so Atlas drifts forward, fragile against giants, vulnerable to grains. It is a traveller in a universe where the smallest things wield the greatest power. The quantum of dust waits for it, as it waits for all. And in that patience lies the truth. Nothing endures forever, yet nothing is ever truly lost. Why does a faint fragile shard like 3i Atlas matter? Why does humanity turn its most powerful instruments to follow a point of light barely distinguishable from the stars? Because each interstellar body is more than a traveller. It is a sample, a fragment of galactic history delivered freely across the void. To study Atlas is to study not only a rock, but the processes of worlds unseen, stars unknown, and planetary systems beyond reach. In the absence of interstellar spacecraft, such fragments are the only physical messengers humanity possesses from other suns. Telescopes can watch distant planets transit their stars, can measure atmospheres in spectral traces, can map galaxies billions of light years away. But no spacecraft has yet left the solar system far enough to touch another world. No probe has tasted the chemistry of an alien comet directly. Interstellar visitors, then, are the only tangible evidence of matter born elsewhere, delivered unbidden into our skies. The scientific stakes are immense. First, Atlas offers insight into planetary formation beyond the Sun. Every star is surrounded by a disk of dust and gas at birth. In those disks, planets are born through collisions and accretion, but not all fragments are captured. Some are ejected, flung outward by gravitational encounters with giant planets. These are the interstellar bodies, exiles from systems where planets succeeded in forming or failed. Studying them allows astronomers to compare our solar system's story with others. Do alien comets carry the same ratios of water and carbon? Do they preserve similar minerals, or are they different, revealing other paths of planetary birth? Second, Atlas may reveal the chemistry of life's ingredients beyond Earth. Local comets are rich in organics, amino acids, sugars, alcohols, molecules that on Earth are essential to biology. If Atlas carries similar compounds, it suggests that the chemistry of life is not unique to this system. If it carries different compounds, it expands the spectrum of possibility. In either case, it informs the search for life across the galaxy. Third, the dynamics of Atlas's path illuminate the population of wanderers in the Milky Way. For decades, scientists speculated how many interstellar bodies existed, but the discovery of Oumuamua and Borisov shattered assumptions. Two within just a few years implied a galaxy teeming with such fragments, perhaps trillions drifting invisibly. Atlas strengthens this view. Each detection refines models of ejection rates, collision histories, and the likelihood that planets elsewhere sculpt their systems as ours once did. Fourth, Atlas sharpens humanity's awareness of cosmic risk. If such bodies are common, then impacts from interstellar fragments are not impossible. Their higher velocities mean greater destructive potential. To trace Atlas's trajectory is not only curiosity, it is practice. A rehearsal for understanding how such objects move and how their paths might intersect with Earth in the far future. And beyond practical science lies philosophy. To study Atlas is to hold in sight a piece of the galaxy itself. Unlike starlight, which reaches us at the speed of photons, this is matter, solid, enduring, born of another sun's fire. It has crossed light years of emptiness to arrive. It carries with it the memory of a system humanity may never see. In it, there is intimacy, a tangible piece of another world passing within reach. These stakes extend even further into the realm of possibility. If technology advances, future missions may be designed to intercept such bodies. Concepts already exist. Rapid response spacecraft capable of launching within years, rendezvousing with the next interstellar visitor. To capture material directly, to analyze it in laboratories, would be to touch the dust of alien worlds with human hands. Atlas is too faint, too fleeting to be reached now, but it prepares the way. Each observation, each calculation, each spectrum teaches how to be ready for the next. In this sense, Atlas is both opportunity and warning. Opportunity because it reveals what the galaxy offers freely. Warning because such chances are rare, fleeting, and unrepeatable. Once Atlas departs, it will never return. If its secrets are not seized now, they are lost forever. The galaxy will send other messengers, but none will be the same. Each is unique, each irreplaceable. Thus the scientific stakes are measured not only in data, but in urgency. Time is short, light is faint, and uncertainty is immense. Astronomers know the odds. Most of Atlas's passage will unfold unseen, beyond the reach of telescopes. Yet even fragments of knowledge matter. A spectrum gathered here, a brightness curve measured there, a trajectory refined by a handful of observations. Together they form a mosaic of meaning. For humanity, Atlas is not just another point of light. It is proof that the solar system is not an island. It is a crossroads in a galactic ocean, where fragments from afar pass silently through. Every visitor is an invitation to learn, to imagine, to prepare. The stakes then are not only scientific, they are existential. For in watching Atlas, humanity remembers that we are part of a larger story, a galaxy in motion, stars exchanging fragments, worlds casting off shards that become messengers. To ignore such visitors is to ignore our own context. To study them is to glimpse our place in a vast and restless cosmos. Atlas may fade. It may shatter. It may pass unremarked beyond Jupiter into the silence. But in its brief crossing, it reminds us why we watch the skies, not for spectacle, but for meaning. Each interstellar body is more than stone. It is history, chemistry, risk and possibility, delivered at no cost but vigilance. That is why Atlas matters. That is why telescopes follow it into the dark. That is why its faint light carries weight far greater than its size. It is a shard of another world, and with it, the stakes of understanding our own. Humanity stands at the threshold of a new kind of astronomy. For centuries, the night sky has been studied with patience and persistence, revealing patterns of stars, the motions of planets, and the faint glow of galaxies. Yet only in recent years has the cosmos revealed its rarest messengers, interstellar visitors, fragments of other suns wandering briefly into our reach. Oumuamua, Borisov, Atlas, each one faint, fleeting, gone almost as soon as it was noticed. If these messengers are to be understood, the next must not escape so easily. The eyes of the future are rising now, instruments designed not only to see deeper into space, but to see faster, to catch what would otherwise vanish. At the forefront stands the Vera C. Rubin Observatory in Chile. Soon its legacy survey of space and time, LSST, will begin, a decade-long movie of the night sky. Every few nights, Rubin will scan the entire visible hemisphere, detecting faint movements against the tapestry of stars. With its 3.2 gigapixel camera, the largest ever built, it will record 20 terabytes of data each night. Within that flood, algorithms will sift tirelessly, seeking the tiny shifts that betray motion. Asteroids, comets, fragments of satellites, and among them, perhaps, the unmistakable tracks of interstellar wanderers. Rubin promises a revolution. While Pan-STARRS and Atlas found one or two such bodies by chance, Rubin may discover dozens each year. Interstellar objects, once thought rare, may become a steady stream. For the first time, humanity will have not anecdotes, but statistics, populations to study, patterns to compare, a sense of how many fragments truly wander the Milky Way. But detection is only the beginning. To understand these visitors, humanity must also learn to characterize them in detail before they fade. Here, the James Webb Space Telescope, JWST, offers a second set of eyes. Floating 1 million miles from Earth, Webb's infrared gaze is uniquely suited to studying cold, faint bodies. Already it has revealed the atmospheres of distant exoplanets, measured water vapor in comets, and glimpsed galaxies from the dawn of time. With interstellar visitors, Webb could split their light into spectra, reading the fingerprints of their ices, their dust, their organics. In the chemistry of such bodies lies the story of their birthplaces, whether in the frozen reaches of alien systems or the warmer zones where rocky planets form. Imagine the next Oumuamua. Rubin detects it early, weeks or months before closest approach. Telescopes worldwide turn to it immediately. JWST gathers spectra revealing molecules never before seen in our solar system. Its trajectory is tracked precisely, its brightness measured daily. Unlike its predecessors, it does not slip away into mystery. It lingers long enough to be understood. And beyond telescopes lies a more daring vision, to chase them. Proposals already exist. The European Space Agency has outlined concepts for rapid response spacecraft, missions that wait on Earth or in orbit, ready to launch when the next visitor is spotted. NASA has studied the possibility of interceptors, propelled by solar sails or nuclear thermal rockets, designed to catch up with high-velocity strangers. In theory, such missions could rendezvous with an interstellar body, photograph it, sample its dust, even return material to Earth. To hold in human hands a rock from another star would be a scientific milestone unparalleled in history. Projects like Comet Interceptor, already planned for launch in the 2020s, foreshadow this future. Its design is flexible. to wait in orbit until a suitable target is found, then redirect itself for encounter. If the right interstellar visitor appears, comet interceptor, or missions inspired by it may be the first to greet such a messenger directly. The challenge is urgency. Interstellar bodies move fast. Oumuamua travelled at nearly 90,000 kilometers per hour relative to Earth. By the time it was discovered, it was already leaving. To chase such an object requires speed, precision, and readiness. The eyes of the future must not only see, but react. The stakes are profound. Each interstellar object is a free sample from another solar system, a gift the galaxy delivers unasked. To capture even one in detail would be to study alien geology without ever leaving the sun's domain. To capture many would be to compare worlds, to map the diversity of planetary formation across the galaxy. Yet there is also humility in this vision. Even with Rubin, even with Webb, even with rapid interceptors, most interstellar visitors will still escape, seen only briefly, their secrets only partially revealed. The galaxy is vast and its wanderers are countless. Humanity can catch only fragments of the story. But fragments are enough. Each one adds to the mosaic. Each one narrows uncertainty, deepens perspective, expands imagination. And so the future waits. Rubin's wide gaze, Webb's infrared eye, the promise of missions yet unborn, all stand ready to turn fleeting mysteries into lasting knowledge. The next Atlas, the next Borisov, the next Oumuamua will not vanish unstudied. The eyes of the future are not simply machines, they are humanity's extension into vigilance. They embody the recognition that our solar system is porous, that the galaxy flows through us, that messengers from other suns are not rare miracles, but ongoing conversations. To be ready is to listen is to learn. And perhaps one day one of those eyes will see not only dust and ice, but something stranger, a fragment that carries within it chemistry unknown or even the seeds of life itself. What will humanity do then? Will we chase it, capture it, or simply watch as it fades into the dark? The answers are not yet known, but the instruments are rising, their gaze prepared. The next messenger will not arrive unseen. In the faint light of 3-eye Atlas, humanity sees not only a traveller, but a mirror. A fragment born under an alien sun now drifts through our skies, fragile, trembling at risk of disintegration. And in its uncertainty, its precariousness, lies a reflection of ourselves, of life on a pale, vulnerable world circling an ordinary star. Atlas is a reminder of fragility. It carries no armour, no shield, no choice. Its path is written by gravity, its surface scarred by dust, its future uncertain with every encounter. It survives not because it is strong, but because it is fortunate. So too with Earth. Our planet floats through the galaxy exposed, unprotected from cosmic violence. Asteroids, comets, solar flares, even interstellar fragments. Any could one day strike, altering life as profoundly as the impact that ended the age of dinosaurs. Humanity builds defences of technology, but like Atlas, we remain fragile against forces larger than ourselves. To watch Atlas risk destruction is to glimpse our own vulnerability projected into the stars. If a stone from another world can be erased without witness, so too could our story vanish in the silence of space. Civilizations, like comets, are temporary. They flare brightly for a time, then fade into darkness. The lesson of Atlas is not permanence, but impermanence. The recognition that survival itself is never guaranteed. And yet fragility is not only weakness, it is also beauty. The delicacy of Atlas drifting against the background of eternity makes its survival meaningful. The same is true for humanity. Life's value lies not in its certainty, but in its precariousness. To know that we exist only briefly, on a planet small and fragile, makes every moment luminous. To watch a traveller risk destruction is to feel more deeply the miracle of endurance. There are deeper parallels still. Atlas is in exile, flung from its home system, cast into a journey it did not choose. Humanity too often feels the weight of exile. Strangers in a vast cosmos searching for belonging. We look to the stars for meaning, wondering if life exists elsewhere, if we are alone. Atlas answers in its own way that we are not. Even in exile, even in silence, we are connected. Matter moves between stars. The galaxy is not isolation, but exchange. This reflection humbles us, for if our world is fragile, it is also precious. We exist because Earth has survived 4.5 billion years of cosmic hazards, enduring collisions, extinctions, upheavals. Like Atlas, we carry scars, craters, faults, memories of near annihilation. And yet here we are, fragile but alive, watching a visitor from another world and seeing ourselves reflected in its peril. The reflection also deepens responsibility. Atlas cannot choose its fate, but humanity can. We cannot alter gravity, but we can build telescopes to see, instruments to measure, missions to defend. We cannot escape fragility, but we can respond to it with vigilance, with wisdom, with the will to endure. To watch Atlas risk destruction is to be reminded that our survival is not passive but active. If we value our fragile world, we must guard it. Philosophically, the parallel between Atlas and Earth expands into a meditation on meaning itself. In the cosmic scale, both are small, both fleeting. Stars live for billions of years, galaxies for longer still, while Atlas will cross our system in months, Earth's civilizations in millennia. Against eternity, both are brief sparks, and yet brevity does not erase meaning. A traveller's story is worth telling, even if it vanishes. A civilization's story is worth living, even if it fades. To watch Atlas, then, is to reflect on impermanence not as loss, but as context. Fragility makes endurance profound. Silence makes presence significant. Transience makes memory sacred. The lesson of a fading visitor is the lesson of humanity itself. We endure for a time, and that time is enough. There is also wonder in the parallel. If Atlas survives, it will carry scars of its passage into the interstellar dark, whispering of our solar system to stars it may never reach. Humanity too carries scars, of wars, of disasters, of struggles, but in those scars lies wisdom. If we survive, we will carry Earth's story outward, into space, into memory. Perhaps one day into other systems. Fragility does not prevent legacy, it shapes it. In the end, Atlas is not only an object to be studied, it is a symbol to be contemplated. Its vulnerability reflects ours, its exile reflects our longing, its endurance reflects our hope. Watching it risk destruction reminds us that we, too, are travellers, fragile, finite, yet luminous against the dark. To gaze upon Atlas is to gaze upon ourselves, set against the infinite. The story of Three-Eye Atlas has always been a story of uncertainty. From the moment it was detected, faint, fragile, already dimming, it became clear that its fate would not be revealed with certainty, but with probabilities, with projections, with speculation framed in mathematics. Its future is not written in detail, only in outlines, in possibilities whispered by orbital dynamics and by the silence of distance. Astronomers project 3 paths, 3 fates that could await this wanderer. The first is escape untouched. In this vision, Atlas weaves cleanly through the asteroid belt, avoiding collisions with fragments large or small, resisting the stresses of sunlight and gravity. It emerges beyond Jupiter, scarred perhaps, fractured perhaps, but still whole enough to continue. Its hyperbolic trajectory carries it outward, past Saturn, Uranus, Neptune, into the icy frontier of the Kuiper belt. Beyond lies the Oort cloud, and then the interstellar dark. If this is its fate, Atlas will return to exile, another faint shard drifting endlessly, unseen again by human eyes, carrying within it the scars of its passage through our solar system. It will be as it was before, a messenger unreceived, a fragment without witness, a traveller returning to silence. The second fate is destruction in the belt. Fragile, unstable, already flickering with signs of internal stress, Atlas may not survive the labyrinth of primordial rock. A collision with even a small body could erase it in an instant, scattering it into dust. Or it may unravel without impact, torn apart by sublimating ices, by spin, by the gravitational whispers of Ceres or Vesta. If this is its fate, its story will end in fragments too small to track. Astronomers will note only that its light has vanished, its trajectory incomplete. The asteroid belt will claim it, adding its alien dust to the archive of unfinished worlds. It will not endure, but it will not be lost. Its fragments will orbit the sun, mingling with native debris, perhaps falling one day into Mars, Earth, or the gas giants. Its exile will end in absorption in the quiet merging of histories. The third fate is a silent fading. Not escape, not collision, but disintegration so subtle that it leaves no trace. Its body may fracture into dust too fine to reflect enough sunlight, vanishing from telescopes long before it leaves the solar system. In this fate, Atlas simply disappears. Observers will search for it and find nothing. Its trajectory, once plotted in equations, will continue in silence, its existence reduced to mathematics alone. It will be a traveller known only through absence, remembered only as a curve on a graph, its matter lost to the dark. Each fate is possible, each is plausible, and none will be witnessed fully. Humanity's telescopes cannot watch every moment, cannot see every fragment. The fate of Atlas will be known only indirectly, inferred from fading light, calculated from vanishing data. Its truth may already be decided, unfolding in silence as it drifts where no eye can follow. But in these possibilities lies meaning. If it escapes, it teaches us endurance, that even fragility can survive, that exile continues, that the galaxy carries its fragments endlessly onward. If it shatters, it teaches us transformation, that destruction is never final, that matter is absorbed, that even loss becomes part of a greater archive. If it fades, it teaches us humility, that not every story is visible, that some messages pass unnoticed, that mystery is as much a part of the cosmos as knowledge. Philosophically, the fate of Atlas is also the fate of all things. Stars, planets, civilizations, all move toward endings uncertain in detail but certain in essence. Some endure, some shatter, some fade. All are remembered, if not in sight, then in consequence, in the transformations they leave behind. For Atlas, survival and destruction are not opposites, but branches of the same truth, that its matter will continue, its exile will not truly end. Whether as a whole body, as fragments of dust, or as a curve of mathematics, Atlas will remain part of the galaxy. The question is not whether it endures, but in what form its endurance is written. And so astronomers continue to trace its faint light, knowing it will soon slip from their reach. The calculations will persist after the light is gone, the equations carrying its presence into the future. But the object itself, stone, ice, fragile dust, will drift beyond sight, leaving humanity to imagine what becomes of it. Perhaps one day its fragments will fall into another system, seeding an alien ocean with molecules from a star long forgotten. Perhaps eons from now, its dust will be swept into the disk of a new star, forming part of planets yet unborn. Or perhaps it will wander forever, a relic of a lost world drifting in eternal exile, never colliding, never dissolving, only fading into the silence between galaxies. Whatever its fate, Atlas has already fulfilled its role. It has reminded us that the solar system is not isolated. It has shown that fragments of other worlds cross our skies. It has reflected our fragility, our impermanence, our wonder. Its destiny may remain hidden, but its meaning is already clear. The fate of Atlas is the fate of all things, to move, to change, to vanish, and yet to endure. In matter, in memory, in mystery. In the silence of the cosmos, 3 Hours Atlas drifts onward. Perhaps it survives, perhaps it shatters, perhaps it fades so quietly that its end is invisible even to the most patient eyes. But whatever its fate, it has already spoken, not in words, but in presence. A faint point of light crossing briefly through the solar system has become a metaphor, a mirror, a meditation. Atlas is a shard of another sun's story. It is exile given form, fragility given motion. It is the embodiment of impermanence, carrying within it both the scars of its origin and the risks of its passage. And in its fragile journey we glimpse our own. For humanity too is a traveller through a dangerous universe. Earth, our vessel, sails a path no less perilous than Atlas's course through the asteroid belt. The hazards are vast. Asteroids, comets, radiation, the slow heating of our star, the expansion of the cosmos itself. Civilizations rise and fall as precariously as comets survive perihelion. Like Atlas, we are subject to forces beyond our control, written into trajectories we cannot escape. Yet in that fragility lies meaning. Just as Atlas is precious because it is fleeting, so too is life luminous because it is temporary. The value of existence is not in its permanence but in its passing. To live at all, to drift at all, to cross even briefly through the vastness of the dark, that is significance. Atlas is also a lesson in humility. It reminds us that our solar system is not sealed, not sovereign. We are part of a galactic ocean in which fragments drift endlessly between stars. Our story is not isolated. It is woven into a larger fabric, a web of exchanges that spans the Milky Way. Every interstellar body that enters our skies whispers that we are connected to other suns, to other planets, to other histories. But Atlas is more than humility. It is hope. For if fragments wander between stars, then perhaps life's ingredients wander too. Perhaps the seeds of biology move invisibly across the galaxy, carried in fragile travelers like this one. Perhaps Earth itself was once seeded by such an exile, its oceans enriched by chemistry from afar. And if so, then humanity is not the first story of life, nor the last. We are part of a continuity larger than our world, a dialogue between stars written in dust and stone. And yet Atlas also reflects the shadow side of fragility. Just as it may shatter in silence, so too may humanity one day vanish, its lights extinguished, its cities forgotten. Civilizations flare brightly for a time, then fade. To watch Atlas risk destruction is to confront our own mortality as a species, to recognize that our journey too may end without witness, our story reduced to dust. But even in that possibility lies a deeper truth. Destruction is never absolute. If Atlas shatters, its fragments remain. If Earth one day falls silent, its atoms will endure. Matter is not lost, only transformed. Memory is not erased, only rewritten in new forms. Existence itself is a brief crossing of vast and perilous space, but in that crossing lies continuity. So Atlas becomes more than a visitor. It becomes a metaphor for the human condition. Fragile, finite, uncertain, yet luminous in its passage. It reminds us that life is not defined by how long it lasts, but by the wonder it inspires while it endures. That civilizations are not diminished by impermanence, but exalted by it. That to drift through danger, however briefly, is itself a kind of triumph. One day, Atlas will be gone, its light will fade, its trajectory will vanish from charts, its matter will disperse into volcanoes. And one day, humanity too will be gone, whether by extinction, by transformation, or by transcendence. But while we are here, we, like Atlas, are luminous. We cross the void together, fragile sparks in a universe vast beyond measure. The philosopher Pascal once wrote that man is a reed, the weakest in nature, but a thinking reed. Atlas is weaker still, a fragment without thought, without will. Yet in its frailty, it has made us think. It has drawn us into reflection, into wonder, into a deeper understanding of our place in the cosmos. Perhaps this is its true gift, not survival, not data, but perspective. To remind us that we are small yet significant, fragile yet meaningful, temporary yet connected to eternity. Atlas will pass. We will pass. But existence itself, the brief crossing of light through dark, remains profound, and so the story closes, not with certainty but with silence. A faint traveller drifts into the void, leaving behind not noise but wonder. And in that wonder lies its message, that life, like Atlas, is fragile, fleeting, and yet immeasurably luminous against the infinite night.